Excited morning. So we have. So let's summarize what we have learned yesterday. So we started with understanding first memory management, and we get into the internals of how the stack memory, data segment, heap memory actually works. Correct. And we also have explored the core differences between different type of object-oriented programming, like generally traditionally how an object-oriented programming looks, and how the modern Rust is actually adaptation. So with reference to that, apart from that, what we discussed is we want to summarize. We did a summary of exactly how pointers are used in your to make memory safety. How exactly pointers are adapted in your Rust. So today, what we will be doing is the today discussion will go on. So we also have described the syntaxes of Rust, very fundamental syntaxes.
Can I? From yesterday's discussion, I got one thing I want to ask if that is true. One thing is that the value types like integers, booleans, and all those types, which normally when we initialize them in a function, they are stored in a stack. If we pass them onto any function, right, they give up their ownership, right, by value. The other types like strings, which when initialized, they give one reference, right? If we give the reference of a string to another function, they also give up their ownership. So when we pass a variable to a function, they give up their ownership or they give up their reference. By default, they give up their ownership. And reference and ownership are exclusive. Once, let's say, a pointer of a string is also a reference to a string, but the pointer to a string does not give up its ownership. The ownership stays with the calling function, but only the pointer is passed. Is this correct, sir?
Correct.
If we pass the and of something, the ownership is not passed because I'm giving the pointer itself.
So yeah, exactly. We did that summarization. So that's exactly. So it means what he was also telling that is, if you pass an address of an object, then what happens is you are still the owner. You will have that. The other person will have that address of it, so you can access it. So you are slicing it. Okay. Suppose I don't want to. Suppose I don't want actually to take owner. I want to become a owner. The other person also want to become the owner. Then what I do is I give this object. So the content of that object is moved to other person. So he becomes the owner, and this guy doesn't become owner. But when it comes, he was just the ownership for a variables. Okay. See, ownership for a variable is all about if you are writing in a function. If the variables are inside that function, you are actually the owner for that memory inside that function. So generally, what we do for a variable, we will pass that address. If you want, you can pass that variable address. If you pass that variable address, how will you collect? You will collect with a reference. There also, you are not giving ownership. The reference is actually pointing to this memory. And still, the owner exists the same one person only, but the reference will do that thing. So then, now today, before we see some programs, but before we talk about this, we will also have to get into something here for me. So this diagram should be clear to you. So this is how we are trying to summarize it. So this diagram should be more of clarity. So now you can, from this slide, so you can tell me in this diagram, the owner, this memory is owned by how many people now?
Which one? First name?
The first one, Pascal.
It is owned by first name.
First name only.
What about name?
Name is owned by greet.
This guy, this name.
Oh, that is owned by greet.
I'm trying to say, just try to understand this one. Pascal is a RO data.
Yes.
That address is stored in this first name. The first name is the person who has that address. That is the pointer who has that address. Now, if I'm passing first name, and what is this guy doing?
It's taking reference, so it is not owning Pascal.
It's not owning. He's only the other person who's.
Still will be able to modify the.
Finally, ownership will change.
See now, who's it?
Sai.
That person.
No. Sai is
Remote.
Okay. So now, if you see, now see for an instance, I'll give you another example. Now you took this guy, okay? You're passing what here?
last name.
Address of last name. So if you pass address of last name, what happens?
We don't pass ownership again,
Hmm.
and we give reference and can modify the value, but not.
How
Can't
can
be
he?
modified,
He
doesn't
cannot
have to
modify
use.
the value. You are
because
this.
it's
This is
not
passed by
used.
So
reference.
it's an immutable value.
It is passed by reference, and this guy will point to the same memory. Now, what we can do on this example is,
So like who is an owner?
so the owner is the person who is actually pointing to this memory. The first person,
Memory
the first
allocation,
one
right?
who was. I'll just show you one.
Only the owner can memory allocate and deallocate.
See, the person who is actually trying to allocate a memory. For example, if you see here, this data is allocated. Owner is allocated by last name. Now, last name is the owner because he is the one who is actually pointing to that memory, right? So now what we do is we are not anyone. He's the owner of that memory, so you don't have to transfer ownership. So you are only giving. You are trying to access the same memory from that reference. That's it. So one point I would like to share 1 minute.
If I wanted to transfer the ownership, how would I pass it?
If you want to transfer the ownership, you can do that. But if I assign it to another object, I'll write again that something is equal to something. If I do that, the ownership happens to only that person. It can only be either a borrower or it can be a owner. Or what you can do is you are not giving up the ownership, but you can create another reference. A reference can point to this guy. So I'll try to show that here.
Borrower basically means when you directly assign
You assign
the
it.
value. So
Yes.
A equals to suppose an integer 8 and you do B equals
So I'll
to
just
8.
show that.
That is borrowing, right? Directly. Then A loses the access to the integer altogether.
So what we are gonna do is, so let me write like this. So let me write down in this scenario. So you see, we will just summarize in a normal first memory way, then we'll try to understand this normal way. Okay, now let me write down something, name, code, colon. So I've written it as string, okay, is equal to, so I'll write down it as rust dot to string. Now, if you look at here, what I'll do here is I will write a function name called owner, and I'm passing here code, and I'm writing another function owner who will receive this C colon to string. Now, this code, which is owning to that memory, was passed to this guy. He has taken that, he moved. You moved it. So what happened is this reference, what it has pointing to that memory, is moved to which guy now?
Owner.
C now. Now C is the person who can access that memory. Now again, I'll try to call owner. If I do this, what will happen?
Error because
Now this data memory is no more owned by this code.
So you're saying that after line number 7, right? If I try to print the value of code, it will not work.
It will give an error. No, so let me see this.
Water. You want some hot water?
Alright.
extra MacBook spare चाहिए.
Spare
चाहिए. तो लगाना है. हाँ. Thanks.
Okay, so let's now you can see here so in simple terminology, if you are looking, if you allocate a memory in heap with make or new or any basic thing, you will get a pointer. Correct. So generally, what happens? We give this pointer to someone to make that pointer to access the same memory. Which memory? Heap memory. But here we are not giving this pointer to. If you are giving this pointer, which is having something, if you give this, so then you can see here.
String allocation takes.
Okay, so
I think Rust is also UTF-8
Same
strings only.
so it is generally
And,
it depends upon the size of the string. So the size of string is what 4 bytes. So 4 bytes plus 5 bytes of memory. It will be
I can understand sized out. You can also unmute and prompt. But so I had this one doubt, like coming from a C. I've also done C. I'm not a C expert, but so in the RO data of, let's say Rust is in RO data, like read only const data. So in the array, I mean in the normal sane world, I'll have R, U, S, T, and then \0. So in Rust, now that the pointer is basically a slice, it will also have the length of the thing. Is there also a /0 in the string constants in Rust?
Obviously, here we do the same.
We'll not violate the good things C has given us.
No,
Just because we added better things.
we have the length. So
We'll have the length, and it will be like 5. We will be occupying like 5 characters in 5 bytes in Rust, which is RUST and then \0. That is there.
So now I'm gonna compile this program. Rust C ownership.c. Now can you see this error? Value mode here. So if you see value mode here, what happened? That address is you have given that address to some more guy. That's it. So that guy has this address. So it means now try to understand that address inside that memory is. See, now I have a question. So maybe in Google or anywhere the terminology, ownership is not to the address of the stack memory. The definition of the stack memory is concept is ownership. Do you understand what I'm trying to say? So what I'm trying to say is the definition of the memory. What is that? The definition of the memory is ownership. Now I'll give you another example. The definition means if you see here.
Give the blue one or the black one.
Okay. So this is how we have the diagram, correct? And this is somewhere we point to this heap memory. That is your Rust, RUST. Correct? Now, what do you exactly mean by ownership here? This address of this is heap memory. This address, what I have. Correct. Now, this address was actually the moment that I have done. Correct. So, what is this guy? This guy is important. It means what? The definition of the pointer. Don't get in Rust any terminology complications. It's only yesterday I've already explained. You have to connect with my dots that I have explained. If you do, it is easy. So it means only this definition. It is only tracking what? This definition. This definition is what? It is a address. Which address it is? Heap address. Now, the moment you have passed that code, so this is no more with this guy. And it has gone to that other person, C. So C is actually having this and pointing this. This guy is no more here.
In the stack, 4, 6, 6.
Object is there. Object is there. Inside the definition is no more.
0 bits. Like
You
0
can
down.
say 0
Garbage
pointing in.
So the C will not get that value.
No, it has
C
got
will get-
already got.
C will have 4, 6,
C has
6.
this. But the moment I do function call and pass code, this address will be given to this guy. So this definition is copied to here.
And that place is zeroed out or just.
Yes, this definition is passed. This you can take that's no more. That object is no more address. It's like it's not even null. We don't call in Rust null. So they're ensuring that you cannot dereference it. So the point in Rust is that they don't want to even put null. Null is not a valid thing. Okay, so they don't want to do that even. So this is the definition. You are only focusing on the definition. The next part is we have another option. What is another option? We'll write address of code. What is that? Address of code. When you get address of code, please, if you pass address of code, then what we do? Ownership is not transferred. You are only pointing to this address.
It's some other stack frame.
You are from this address. So let's say this will also have address, right? So 566.121. Correct? If I pass there in my code, if I pass here, what should I pass here? What should I do here? If I write here address of code, what happens?
And str.
If I write down here also address of code,
Here valid state.
I have to write down here
ampersand string also works.
Amazon string doesn't work. Only string works for when you allocate a memory that to keep, then you have to use string. This is a different type.
I just did it.
If you write it, it will give an error because mismatch of type. Mismatch of type it doesn't. If you do this ampersand of string here, what will happen? Again, if you are doing that, then I'll just come to that point as well. But what happens is again you are going to reference to that memory. Reference again to reference concept. So if you let's now do this part, so then I'll come to that part. Okay. Now if I have done this part, okay. Now in this case, what happens? If I write ampersand code, what happens in this case? In this case, what happens if I write ampersand code? Anyone can give me a try. What happens if I write address of code? You will get this guy. No, you will get this address.
Double point.
Yes.
If you get this address, there will be one more person who will have this address. From this address, he can dereference this address. Correct. So this is actually in this case, this is not the definition is not passed. But it's not passed. The definition of the object is not passed. The definition of the object is not passed. Then no. So terminologies you keep that ahead, but I don't follow that terminologies. I follow the understanding of the memory management. So when you follow that, it is easy. Now you are trying to pass ampersand of code and you pass their address of string. Correct? Tell me if you pass address of it, this is passed. Correct? So then tell me what is actually, there is a catch here. So what is a catch you have to understand is for string guy, the object will have three things: pointer, length, and capacity. What is that? The object should have what? Pointer, length, and capacity. So what if you write pointer, length, and capacity, and you are passing their address of code? So if you pass address of code, let's say this is the address. Inside this it says something, and you are again collecting C colon ampersand. So again, what happen? What should have here? This guy should point to some heap memory. Now in this case, what will the definition come? What should the definition come?
466 something.
Yes, what will be the definition? The diagram I have put already. So what will be the definition if you do in this case?
And string. I think it should be 566 because I'm passing the address of the another address.
You can see here.
It is like a move only, but it is like a clone. Oh.
It is no. You can see now. I'll write like this. Okay. You
not saved it.
Save.
No,
Command
not
X.
So there is a warning. I need only the memory diagram. Tell me the memory diagram. I want that memory diagram. What happens to that memory? In that memory, what happens? You know the diagram of the memory, right? So tell me what happens to that. See, that is an address. So what that pointer and length and capacity will have, and what will that definition be?
May I try?
You can try. You can tell it directly. It's simple.
Okay. So this is that string we are passing, right? Something.
You asked a very good question.
Okay, and then this is the function,
The
right?
code.
No.
It's address of the code, right?
No, address of not code. So it's not address of code. I'll tell you. See, actually code was having this. It was pointing to some memory, correct? Now what did you write? You write your address of code. What did you write? Address of code. Generally, I'll give the tricky answer. I'll give you the tricky answer. If you write here address of code, now what I am supposed to do here is I am supposed to. What will it do? Now it will not change the ownership. It will refer to this address itself.
One
more
more
object
object.
no, sir.
It is one more object. No, it is one more object only. But this will point to this guy.
Yes, that.
This address, not definition. It will go to this address. So when you are doing this tricky job, yesterday we had one question, interesting question. I was passing ampersand of something and passing normally. So both was working. I told you, right, ampersand of error and error will give you same thing. Same thing. I just gave you that definition, right? So that's the tricky. So you get this. Yeah. You are not changing the ownership. You are not changing the ownership. But you will get this address. That is the reason.
It's like a C type copy.
See,
sir.
it is all C type copy only. So it is all happening with reference to reference, or you can tell the word called pointer to pointer.
We are like passing the pointers by value.
Yes, no, you are not passing by value. Here, what happens is, one diagram I'll show. Please, one diagram I'll show. No, one diagram I'll show. I want to explain this so that this diagram is going to give you a lot of clarity. Okay, so one diagram. Okay, I am writing a EA which type is I32. Okay, so the address is 1466121131415. Okay, there is one more type which I'm writing another type as well. So the address is 4661. Generally, stack will be high to that order, right? So I can even put this. I can even 13 means I can also start with something. Let me put something random. Okay, 16, 17, 18, 19, and let me put this one more address. 20212223. Okay, so I'm gonna. This address is what. Let's assume this is a pointer. This address will store this here. This is a pointer. This is a type, and this is a pointer. Yes or no? So this pointer will hold which address? The first address. Correct? And let's assume this is a double pointer. What is that?
Double pointer.
Double pointer. Now I'm going to tell you an interesting topic today. This is going to help you a lot. Please try to understand. This is again address. This is not a normal pointer. This is a kind of double pointer. Now this pointer will hold which address? This address. So by this, what I can do? The concept here is if I write P1 will get me what this definition. The definition of P1 is nothing but the address of this pointer. If I write a star P, if I write here P1 will give you this address. Correct?
Correct.
If I write star P1, what will it give? It will give me address this address. That is nothing but what? 461412, 46611412. Sorry. No, not 412, 416.
416.
Yeah, but if you say like ampersand P, right?
Ampersand P will be
Ampersand P
give
is
this address.
actually-
This address.
Yeah, it will give that address.
That is.
So what we are passing matters. It's not what we receive.
Yes.
So when we are passing like ampersand code in this case, because code is like an array.
Correct.
So when we are passing ampersand code, we have to receive it as a as a double pointer.
Point only.
But we are receiving it as a ampersand str.
No. What we are trying to write, what you said is correct exactly. But this is the generic concept. But here, this is I've told you the basic concept. But here, what happens? You have actually two memories. This is one object which has pointer. It means now you are not actually passing. In this case, you are passing only this address. Correct? Only one memory address. That's a pointer. But in this case, you are passing an object address. Object address means what? It is total size of the memory. It is, let's say, if you have here 12 bytes of memory, then you're passing the first address of 12 bytes. You're passing the first address of your 12 bytes. So when you're passing the first address of your 12 bytes, this guy will be holding which address? Now, what is the address he has to store here?
First address of
First address only he should store. Now, what is that he has got is he can go and access the whole entire 12 bytes because he is given, he was done. It means what? From this he can access everything. So that is the benefit we tend to store here. It means if your object has the starting address, from that starting address I can access all the variables or all the members. So that's the reason they're storing it. I hope I'm.
So, sir, it is just a simple reference passing, and it is not ownership passing. It's just simple reference passing.
No, you don't use the terminology today also.
Okay.
We will conclude the terminology tomorrow only because today also still in mind some glitches will be there. Exactly the core terminology we'll talk about tomorrow only. Okay, so that today also we'll do this thing and tomorrow we'll exactly get into this. So this should be clear, right? So exactly what we have done there. Okay. So now this is almost clear. It means always keep a note of it. The definition of the memory, if you're passing, then what happens? You are moving that ownership, right? And what is slice means? You're not passing the definition of that. You're not passing the definition of it. You're passing the address location of it. You're not passing the definition of it, right? What are you passing?
Address.
You're passing the address location of an object, or you're passing something. Then that is, what is it called? Slice.
When you pass a string and receive it as a address of a slice, you are making a copy into that only memory, right?
No, I am not copy. Again, repeat it. What you're saying.
When you passed owner at the code, you gave a reference of a string.
See, now
Reference of a
one
string
minute.
object, reference of a string object.
See. Now what you treat it is, you treat everything as object now. You don't treat anything. Okay. Now you tell me. You are passing an address of an object. Now you tell me your answer. Question.
Now owner is accepting, let's say, as address of str. Okay. And so it is an address of a slice.
Yes, obviously.
So
If I write address of str, it is a slice. So I'll tell you exactly how this is managed. This is internally managed using tryte concept.
so sir,
I will tell you that
But-
tomorrow.
but
Okay,
that-
internally that will.
That string was in heap, right? Now it came into this automobile.
No. It's not coming into Argo data. That's what I'm trying to give you clarity. It is this address only I'm getting.
Okay,
I'm not getting the definition of that memory. That's why I'm saying it.
that is still in heap.
That is still in the heap. There is no change to that. This definition only I got it there.
but you accept it as an address to a slice, no?
Yes, you can say an address to a slice
So
or
why
object
is
to
the
a
string
slice.
object?
Yeah. So that is
Why is a string object looked at as a slice? Why is a string object looked at as a slice? Like
See,
why
you can-
typecasting it like a slice.
1 minute.
Why
See,
we're passing it is because we don't want to change. We don't want to worry about it yet. We just want to access it.
So typecasting
Okay.
can be done.
we can do, but I'll tell you that. Okay, now we will do little more changes. Please hold on.
Basically, in the function where you are defining the argument, you have mentioned ampersand, right?
Correct.
While calling, you are passing the reference. So when you have mentioned ampersand string in the function definition argument, so basically that will do dereferencing, right? That will point to the actual value where the the actual value which is stored in that particular reference. Correct.
Exactly.
In Golang, you have star in the function definition. Here we have ampersand all the way, both while calling and while receiving. Right?
Your point is correct. I'll clarify it 1 second.
Yeah, I tried. Same. I passed ampersand code in the first call, owner, then printed that in the
You
function,
can
then
turn on auto save.
again printed code.
You can turn on auto save. Accept it as file. From file, there is an option auto save. Below. Yes. Now it will.
Send it.
Okay. See, I want to see. This is something that your in your memory it is running, and if you see that, did you get both the cases rest? Okay, but how did this happen? So your point also I'll clarify. So how did this happen? I passed the address of code. I received it here. So how did this happen? Now, how is this internally happening? I'm asking.
Yeah. So basically, first call owner where you are passing the reference of code. While receiving in the owner function, you are dereferencing the C, right? You are using ampersand string. So basically, that will make sure that you are again pointing to the value of the reference.
Okay, 1 point.
Value which is
1
stored in
minute.
that.
1 minute.
Point
See,
of
one-
will be passed to.
I need attention. One second. Okay, 1 second. Okay, I need an attention. Listen. If I have an address, I want to explain like this. Okay, this is one address. Okay, this address, if I directly put inside, I have a pointer. Okay, I have a pointer which is directly having this address. Okay, this is a pointer which is having this address.
Yes.
Now tell me, if I pass this pointer, now carefully listen. Here is a trick that will solve all your points. I'm trying to think how I can present it to you. Now, if I pass p, what does p means? The definition of the pointer. What is the definition of the pointer?
Of the value
This
of
address.
this.
Obviously. So if you see, I'll try to put it this way: the address of this pointer is different.
Yes.
Okay. Now clearly understand it. The address of this is different. The definition of the pointer is different. Okay. Now when I'm passing p means what I'm passing? Definition.
Definition.
Definition. So definition, how will I collect? I'll collect something like something I'll write here p colon star something I'll write. I that it.
Yeah.
Something. Let's say this. Correct?
Yes.
Now the question is, if in rest, if you pass ampersand p, how do you collect?
Ampersand I-32 or ampersand string.
Correct.
You need to dereference it.
You need to do that. But now listen. That if you are passing this address of p, this is where your confusion starts. Wait. I'll clarify. You ask the question. 1 minute. Now if I pass address of p, what I'm passing? I'm passing this address. It means what address? I'm passing pointer address. I am passing pointer address. I'm passing what address? Pointer address. Now who can hold the pointer address?
Another pointer.
Another pointer can hold. Can you do all this thing? So what you have to imagine in your mindset is, whenever you are using ampersand, means what you have to imagine in your brain. If you read ampersand means, what is your imagination? You are getting some address. It means it is which address? It can be, the rest idea is, it can be the definition, or it can be the address of that object also, you can say. So that is the reason that writing the Saman symbol you are writing there. You are getting my point now, how I'm trying to explain it. Now this is the reason that they are trying to put in this question. What we had a challenge, address of code and code. Pass address of code and code. So there was a challenge. Yes or no, guys? So we started getting a problem, and that problem is a solution. And now you ask one question. You are asking one question. So for your question, what you asked, okay, that is in respect to which you said language, right?
Yes.
Okay.
Then we use asterisk in the function definition when we are about to receive a reference to an object. We reference it while using it in that function.
See, in Go language, you will be not writing ampersands. You will be writing different. You will be writing p. You write p star int. Okay, or you will write here. You will write even sometimes you'll write star int. If it is an array, then it is different case. So you will be doing different case.
You are telling while
Passing.
declaring the
No, when you are passing, I'm telling.
While passing, we can use ampersand. We use ampersand.
No, we don't use passing. Okay, receiving. I'm talking. I'm telling
Receiving, yeah, star.
Yes.
Yes, correct. That's what I said.
Yes. So you
While
are
receiving, you will do star to dereference.
See, whenever I'm passing anything, I'm passing something here. You pass here ampersand.
Correct.
Correct. When you're receiving, how do you collect? Right here, star.
Star. Correct.
That's it. So you pass address, you receive is a pointer. Is this clear? So that is same thing. But here, so in your terminology wise, when you are passing, you are writing the same thing there also. Address of code. Okay, but receiving part, you have to write the same thing. It is that you are writing. So what I am trying to say is, because it's being an object, so you need to first don't try to understand the terminology. Try to understand the memory layout, and then you will understand everything. Okay. Now, you have any question? Anybody has got any question? Now we have to go little other topics. So if you have any questions, we'll rush. Any doubts? You have any doubts? No doubts, right? Tell me. Okay. Correct. Correct. What you have written is correct. So you are trying to say this address you are putting here, not this address. This has again address. This address you are putting. You should put here.
So this will come over.
Mm.
So once this comes over
Mm.
so we are again printing.
We are dereferencing this
So-
and getting this.
So we are again like dereferencing.
Correct.
So it will happen intermittently.
And it will dereference it.
So we are not actually moving the value. We are just copying the value.
Yes. No, we are not moving the definition.
Reference the-
Moving the definition of this is important. What is that? Moving the definition of it is important. Object has definition, na? That is.
Like suppose I want to move the value. Actually, I want to
Then you can directly pass ST here. And receiving part also should write C colon string.
But the actual ST will use it.
Actual ST will use it.
Yeah.
So it is object based pattern. So don't treat because it is object based pattern. Don't treat like that. Okay. Is this clear?
Yes.
Okay. Now we'll go little different way. So here, okay, I am writing a structure. Okay, I am writing a structure. The structure name is data. Okay, the structure name is DB. Inside the structure, I will write some variables. Employee ID. Employee ID type I can write here I32. Okay, I'll write one variable. Now, my question I'll ask you. I want to allocate memory for this I32 in heap. How can I allocate?
using box first.
Okay.
Smart.
Okay. I want to allocate memory for that. I want to allocate in heap.
Okay.
How can I do that? Okay. So you have to write like this. Let B is equal to box scope relation new. What is that? Box scope relation
New and then the value.
Yes, you have to pass. You can see that the function new is actually taking X type is generic and returns. I'll talk about any of this. This is allocating memory only. So it allocates memory and that. So now you see now what should I pass? Guess it what I have to pass. No, I want this employee to be allocated in heap.
Okay.
DB.
If I pass DB, will it work? What will if I write pass DB, will it work? In Go language, you do the same thing.
DB.empid.
No,
You
no.
need to provide
You
the
cannot do
employee
that.
ID also.
You cannot do that. Now see here. I'll do this. You'll get an error. It will tell you have to you can see this. You have to see the error. Convert into that is the first. It is always that. I always do this. So let's now start writing this. So now this is done. So rest. So what is the error I'm getting? See there. It is actually you can see that it says you have to initialize like DB like this. It's saying that, right? So what if I do? What happens now in this case? If I write now DB, close bracket,
Structure with an I32.
which is I32 type, and if I write down now here, what I will write down here? EMP ID colon some value. Something 1, 2, 3, 4. Okay. Now this employee ID is stored where?
Okay, this one. Read only.
Heap.
So everything will be stored.
Okay, you use new, right? So
It's in the heap.
It's in the heap, right? Everything.
Heap.
So now
B
just
in the
tell me
stack.
how will this object look like? How will this object? Now B is
In the stack.
now B. What is B? Now if I want to pass this, how do you pass? How do you do this? So I'm doing this. So okay, first let's clarify like this. It is very sure that new is going to take a type. It is DB. DB is an object. So it'll store that DB. Where will it store that?
so
What will the new will store of DB type?
object definition should be in the stack, or that definition, the object itself will be in the heap only.
There is a catch here. So that's this catch we have to understand. Okay, one more point. Hold on, I'll do one more way. So then you'll see this. So let me create another object here. Something psi is equal to, and I'll create an object here. What is an object? I'll write like this. So I'll write down, I can pass some employee ID. That is, I'll pass here some employee ID. So I'll pass some different ID. Okay. Now this psi object, where does it get memory?
Read only.
I will
Stack.
use stack.
Stack. Okay, very good. Now I will pass here. If I write down here, I'll pass here psi. What if I pass here psi?
Psi will get
What
copied.
will it actually store?
We can do this thing, sir. I don't know.
Okay, this is where we are going little deep. So we'll do this and then we'll come to this. Yes, tell me.
Reference of psi.
Okay, so what if this is psi is an object, correct? So what is box coefficient new? New will take a type. So what type of it is psi? So what will it do?
TB is the type.
Okay, so now 1 minute. So you can do one concept here. This is little tricky, so I'll show you with the diagram itself. So as you know that db is an object, psi is an object, correct? So write down psi here, okay? And psi has only one variable, correct? So it has only one variable called employee. And what was the value it was storing? 1, 2, 3, 4, 5. Correct? Now if I write b is a box object, correct? It's a box type, right? So what is new taking is it? I'll give you a simple question. You know, new in Go or or Python that didn't
You
come.
will allocate on the heap, right?
Yeah, it will allocate in the heap. So if you write a new and you write a type,
It needs a type.
it needs a type.
It's
So if
not
this
data.
type will allocate, you need to just tell a type. And this type is integer means it will allocate 4 bytes in heap and give you that address. So if you write a box dot new, I'm writing there inside that I'm passing psi. So what is a psi? Psi is an object.
It's not a type.
It is an object. I'm passing an object. It means even an object is type is also identified as db. Because object type is what? db. So it will try to understand that you're asking me to store this object inside this object you are trying to store it in heap. So how does this look like this diagram you see? Now what will be the b? Box object, how it is the internal thing? What will the diagram of box object? What does box will have? They will be also reference inside? Okay. So 1 minute. So b is an object. You can say that, but this is a little different. It will have previously what was a normal person will have only like length and something like that. But internally they will use something called here, something concept of reference count. What is that? So they'll use something here, reference count concept here. Okay. So we will talk about this now. Here I'll try to show you that as well. But before this, now tell me B will have, what will it have?
It will have a pointer to psi.
Mm-hmm.
It will have a pointer to psi.
Okay.
Psi will-
So if it is having, okay, if it is having a pointer to psi is already here.
Psi.
Now what does it has? It is not the, does it has a definition or does it have this thing?
Psi has the
I
definition.
think
What we go by.
it will be
Now
more,
if
right?
if I see the whole point you didn't understand. I'll tell you 1 minute later. You are not getting the concept. If I write, because I have written in my code I have written psi. In my code I have written psi. What happens is the data what psi has will be copied to heap memory. Do you agree?
Yes.
Because it means there will be a heap memory allocated for what data? 1, 2, 2,
1, 2, 3.
3,
Five.
5. There is a heap memory allocated. Correct? This data is copied to that, and that memory address is what box will point.
But the dereferencing, automatic dereferencing, how will we override that?
This automatic dereference, that's what called this automatic dereference only. I'll show. We can dereference this whole content.
Usually when we pass something, right, like, so its definition will go, right? So like size definition is the address of 1, 2, 3, 4, 5. It is not the value of 1, 2, 3, 4.
No, in this case, if you are passing an object by value.
5. Right? But see, like size is not pointing to 1, 2, 3, 4. The size
No,
is
psi
not-
object content has that. So this psi object is this type, which has this content. So I am passing this content. The data in this is passed. And now in its simple way, you are passing new of 1, 2, 3, 4, 5.
Correct. So it should be psi dot FID, right?
No, not necessary to be passed. You can just pass an object itself. You can just pass an object itself. As you said, you can even do that. Psi dot You can also write that psi dot employee, but we generally do this style of memory allocation.
But in that case, that will be 932, and in this case, it is type PV, no?
Yes.
That is the difference.
This is the difference. So you can see this. But now what I will do is, I don't want to do this approach. But let me be very honest. We want to store an objects which is either two types of object in real time in Rust. Generally, one we will try to store array of structure objects. What is that? Array inside that many structure objects, or array inside that lot of map objects. You will see in real time, generally in your APIs in real time scenarios, you will be getting combination of the data is, you only wrote API, right? Your data combination is an array inside that lot of map, what combination you receive. Remember?
What combination is it like?
Data. When you are giving a response or when you are taking input. Okay, but generally from my experience, from what I have seen in my experience, the data will be in this combination. I think you know Jason also, right?
Yes.
Yeah.
So it will be an array inside this array.
Structures.
Either it will be a lot of structures,
Array of structures.
or it will be an array which will be a lot of dictionary hash maps.
Yeah, right.
So if you want to store this all information, generally in Rust, why performance is super ultimate is, guess it, why it is super ultimate?
Low level.
No. So what they are trying to do, is, if you are trying to, there are two benefits here. You can, in both the ways you can do. Now, okay, in this case, you have allocated memory in heap. That's done. Now, what if I pass address of psi in new? What if I pass new ampersand of psi?
So ampersand of psi will be a stack pointer object, and you will get a copy of that pointer object in heap and a reference to that pointer object in heap.
What if I pass address of psi? What will happen? Just now I told the point. You will get the address of this. Yes. So Rust is fast only because of this. If you create a structure, I don't copy the content of it. I will hold the address of it. The same thing happens in C also. We will do that, but generally little different. I will tell you that this is little different. I will give you that thing. So here we will try to pass this. We will try to store only this addresses instead of. Are you getting what I'm trying to say? No?
Function argument we can pass
The address of the structure.
See, in Go language that is little different. So what I'm trying to say is, in Go language we don't need to pass the address. We directly pass the ownership of the memory.
But
we can do that.
We can do that by receiving star. We can do that, but nobody will do. Yesterday I told, na. It's a best practice. If it is a best practice, I'm telling. Generally, okay. Let's assume. Yes, you know, you will do it with pointer. Let's say I don't know. I don't do it. So what will happen in that case?
In Rust,
So Rust it is enforced.
You can enforce. In Rust, it is enforced that you will be sent like this.
Even if I try to send something by value, it will be sent by reference.
It is not you send by value, but you have to enforce to send this approach.
So the compiler will
Yes.
hold a gun to you.
Yes.
Say,
So you need to ensure that that process is there. Now I'll just try to show you there. You write down here new of. Now I've written this, right. So now what I've tried to write is I've just so we will do one. I'll try to. So there are two objects here. Okay. So what you can do here is, as we did here, we'll do a basic print alert here. So can I print now if I write B, what will be the value of B? Okay, it's going to automatically dereference.
Yes.
So what is the value it is supposed to give? Because I passed 1, 2, 3, 5. So it's supposed to print automatically 1, 2, 3, 4, 5, right?
Psi and
Psi and
structure.
Okay.
You just did a structure, right?
No, what I am passing, psi is actually an object. You can see here.
Oh, you have to implement that display.
Okay, I have to implement. No, I have
Colon
not.
and
I have written colon question mark.
colon
here.
question mark.
Okay, yeah. This will print the address.
Now, if I do this, is this going to print the address or it's going to print the value?
It's going to print the address of the B.
Value, it should print value.
Okay,
No,
no,
debug.
I have to write again
The
hash.
debug.
I have to write a derivative.
Yeah, hash.
So what I should write down is I should write hash here. What is the hash symbol? Then what I should write here? Derive,
debug.
and inside that you should write debug. You should write them. So why I'll tell you this, because this is this line, one line. I'll anyhow explain you this tomorrow how this line actually works here. So we will write now. Okay, sorry. Okay, there's one semicolon. So now I'm getting a warning. That's not a problem. Okay. So now what I'll do is I'll write down so what did you get there?
That's structure.
The content copy.
Yeah.
It means what? There is a new copy. Now what did happen? If you answer this diagram, you get one chocolate. I'll tell the answer. From stack memory, the data got moved to heap memory. A stack memory had one copy, it is copied to heap memory. So this concept, why I'm telling you this concept is, do you think you will do logics, right? So what do you think the kind of logics we will do in Rust? So in Rust, when you're doing with any data structures objects, we will try to either two approaches we'll do. The content of that heap memory will try to copy to stack memory, or we will try to again reference that. We can even do that. So what I'm trying to give you example is Sai is actually an object which is stored where stacks. Getting it or not? I passed the Sai. What happened? The content of that is again copied to heap.
It would be like a move operation.
No. I passed just Sai. Sai is just an object. The content is passed. Now what I should do here is, I'm supposed to pass here ampersand of Sai. What if I pass ampersand of Sai? I'm passing an object address. So what will happen? He will not allocate memory. He will have a reference to this.
Yes.
In heap, you are having a point to reference to this. Now see.
Heap has a pointer to some place in stack.
You can see that. It will now when you do this, what will happen? But actually, Sai is which kind of memory?
Stack.
But this is which memory?
Heap.
So which has more scope? What is the memory scope? Sai is also till end of the function and B is also end of the function. Will it throw any error in this case? See there. Did it throw any error? Why didn't throw an error? Because of the scope. Are you getting? It is not actually trying to store the data. It is storing the address of it. Getting my point? Now that address, it will try to store it. So this is an efficient.
So is a reference to a DB.
Yes.
Okay.
You can say that is your imagination. How you want to put. If this is how you want to put that imagination, you can put this. Okay. Now this is whole thing is clear now.
There is a scope mismatch will get an error.
Error,
Then in that
definitely.
case, the first one when we were not passing the address, we should have got an error.
No. Scope mismatch is not a problem here
No,
because
without the ampersand, without the address. So because Psi would be a stack
correct.
and B would
This
be
will
an
be
heap.
heap. Yes.
So the scope is mismatched.
No. Now the scope is same. See now. See because this is in. If you had, let's say this guy was a function call. You did a function call and returned it, and then that case it may be a problem.
We can check like put
You can write a function
in
and
a curly bracket and we can check.
we can do that. So we will do that as well. But before this, we have to do something else. We will do that as well. We have some examples. So okay, now this is clear, right? So now we will move to. There is another important step. So 1 minute, we will just have to get into that other important step. Okay. So before I talk about this, so this diagram you get into this thing. Okay. So this diagram, below there is a link here for you. There is a link in that diagram. Can you open that link below link? Yes. The code you will see in C. So you need to see, open that link.
Safety.
Open that link.
Okay.
Did you open that?
Yes.
Open, right? See, is a very versatile coder. Okay, now go to that code. Now don't forget about as of now Rust. Okay, you all know C basics. So what is that? No, you can see here only. Better one screen. Okay, there is a structure. There is what?
Start data pointer.
There is a length. There is a capacity. There is a structure. There is a pointer. There is a length, and there is a capacity or not.
Yes.
Okay. Now listen carefully. If you look at the basics here, you are trying to okay, this is not a problem. This is not a challenge. They are writing some functions. This is all C code. So forget about C code. This is all C code, correct? Come on, yeah, it's all C code. So you forget about C code. So what is that they do? They do malloc, right? The crazy thing is you have option in Rust. You can also do malloc, but there's a different way. You can do that. Okay, we are not talking C. Leave that. Okay, can we move to? So if you see this kind of coding style, what will happen? Can we do this kind of coding style in Rust? You are calling one function. He is the owner of that point. Definition of the pointer is with him. If you give that definition to this guy, what happened? That guy is gone.
Yeah.
So he becomes, this guy becomes owner. Yes or no? When he becomes owner, if I'm passing this vector, what will happen? The other function will receive it.
Yeah.
That fellow will become owner.
Yes, sir.
Right.
Getting my point? Huh?
So vec new is allocating in the stack only, right? In
Yes,
the C
yes,
code.
yes. Okay. Now after that, in Rust, if this program will not work, because why?
Ownership
The
is
The stack has
vector
been
address
popped.
is passed to
Yeah.
him and no more collection.
Yeah.
You will not be able
The
to
stack
access
has
it.
been popped. So on different OS, you can't be sure that the
Yes.
stack is still yours.
So again, if he is doing this style of line of code in C, it will give you an error.
I mean, in Rust, no, C it will work.
See, I'm trying to give you a simplicity. Okay, now we will go to the actual concept. So, the basic things is you all from basic background, everyone knows. First we will allocate memory. It means when you create an object, what happens, guys? Exactly, we allocate some memory, correct? We don't know exact size, so we'll allocate some. If you want to add more memory, again we call method and extend the. So what do we do? Only extending of memory. Are you getting my point, right? Okay, now I'll show you the diagram. Don't worry. I am just taking this reference. Look at the diagram. This is how they will implement a vector. What is this? Struct vector. Inside there is what is this? Come on, it is a I size. I size means it is the size is independent of. It's a kind of.
You size underscore T in C.
It's a kind of thing. So it is. You can say I size is architecture
Signed.
dependent.
Sign
Okay.
size, I think. Sign size.
Okay, and you have written this box type. Okay, you can forget about this. You try to listen. The important thing here is that if you write a structure inside that, if you write down like this type, length, and capacity, you can also allocate memory. Understand? If you are trying to write like this, there is a function new. I will write now code. If I return that reference, what will happen with reference? You're creating here object, right?
The stack.
If you return that reference, what will happen? He will see that. What is it? Expected what?
Lifetime parameter.
So why is he going to give this error? Because now listen, what is the scope? No. This is a stack object. Stack memory. Once you end this object, what happens?
Stack goes popped
This
off.
deallocation.
Yes.
So if you once you enter object, you don't have access to that.
Yeah.
So if you are returning that address of reference, it is not valid. So what is the option here? So
Heap.
what they'll do?
I'll create the vec in heap. Vec 2.
What he is doing now? See now, what is he doing? What is he doing?
He's creating
Changing the
No, he is passing that copy. Don't get confused. He's giving copy. Are you getting it?
Can you go?
I will give explanation. No. I'll tell. No problem. Bus here, this is an object bus. This object is stored in stack bus. Okay. Bus, when you pass that address bus, what will happen? Bus, once you enter function, you are passing address of that memory is no more accessible. Correct? So what is the option we have? Copy.
Copy it.
So how do you copy it? Return type will be VC2. What will happen? The content of this one object will get one more copy.
Okay.
So we are assigning it and we are returning it, but not the address. We
No,
are
not
returning
the address.
value.
We are getting the content of that value.
Okay. That is the definition of the
The
object.
definition of that. The definition of the object is what? What is the definition of the object is? Now I will try to make this diagram simple. No. Forget about that. So you see this diagram. This diagram is like this. So there is a person called data. There is a person called length. There is a person called capacity. And this data was pointing to some heap memory, correct?
Yes. Keep the integer.
Correct?
array.
Now there is a tricky part. Listen. If I return type is again BC2. BC2 is a vector structure name. Correct? If I do this copy, what will happen? This will be again getting copied. Yes. Okay. This will be copied. Length will be copied, and capacity will be copied. So one more person will be copied. One more.
Yes.
One more copy will come. Now this is given to someone.
The caller.
So it is, I can give this to someone, but this is also there. But anyhow, this memory is once you end up the function, we say that object is dropped. So what happens is, listen carefully. This is an advantage. So what happens is he will lose access to this memory, but still there is a reference which is still pointing to that memory. This guy is pointing.
Yes, sir.
He will be losing it reference, but still this guy will access that reference.
The copy will have access, but the function loses access.
But the function is not existing
Yes,
now.
exactly.
The scope is out.
We can also do that by passing static, by returning static.
You can do that by returning static, but generally what is a suggestion we will follow here is, if there is any reference to heap memory, this is a preferred approach.
But again, like if you want to, for a period, if you want to initialize some global value, then we can do that by passing static.
You can do that.
So
If
it
there is
will
a
be-
global variable, you can
so
do
it can be applicable from.
that. Yes. So let's now do one more agenda. I hope it is clear.
So in the previous example, we were passing the pointer back, and in the newer example, we're not passing the pointer, we are passing the object. That was the difference.
So
Right,
the difference
right,
is
too.
the difference. I'm going to
Yeah.
write a code for this and show it to you. The difference is we will write a similar style but little different. Okay. So what I am trying to say is, if I pass address of V is a local object.
So I'm passing the address to a stack variable.
Yes.
This does not exist technically, because the stack has been popped off, but C was okay with it because C is C.
So what we will do is we'll take a new program.
In C also, I think
We can do it.
we can't return the address of an object which is going to be
The stats.
scoped out.
No, we can
we
return.
can. C is-
But
I mean, we can't return, but we can't do it.
we can return and some compilers, if you return and after the end of the function, you are able to access the data. What they are trying to do
It's
is
risky.
So it is a risky always code, because in Linux what happens, whenever you call one stack, it has to immediately reuse that same stack to another function. It is not reusing. So after some time that memory is usable. That's why it is becoming accessible, but it is not valid.
So here we are saying that error will be caught within the function.
Yes. So now we will talk about the return type. We'll see that, right? So struct vector. Okay. So let's say I'll have a length which is of type I32, and I'll write a capacity. Okay. I write a capacity that is also, let's say, I32. Okay. Now what I'll write here is okay. Now generally what I will be doing here is I'll write a method. How to write a method? First, before method, we didn't write a function. So let's write a function. So first we will write a function. So name of it is it's
Distance.
some method. It is a function. Okay. Now inside this function, generally, if you want to make a costly affair to a company, then you are passing lot of by value. If you want to date that company, you have to pass by reference. Which is your choice is your choice.
Dating.
Yeah. Careful, but HR listens next year.
Posh.
You already got a seminar on sexual harassment.
Okay.
घाटा नहीं कराना है ना.
Okay. We all are REST programmers. We'll only date REST. Correct or not?
Yeah, rest.
Yes.
Abhinandan married.
Uh-huh. Okay. Now let's write down like this. So what is the type of it? So let me write V, and type of that is what? Vector. And so I'll be expecting a vector. So in this main, so what I'll create is I'll create an object. Let obj is equal to. So what should I write here? Vector, square bracket. So what are the two variables I have here? Cap. So that you write 12, then
Len.
and you write something 23. Okay. Now I will call this function. What is that function I'll call? Set. Okay. And I'll be passing V. So what I'm trying to do is the object has 12 and 23. The content of that object stack is traveled to another memory. So that is which memory? V. This memory and this memory both are different addresses. Both are different addresses. This is different. This if I'm passing here obj. Okay. This V, different memory or not? They got a content copy. They got a content copy, and that has no problem.
OBJ will lose ownership.
But
No,
ownership
nothing.
will-
No. Here,
OBJ is not a pointer.
no. 1
OBJ
minute.
is object.
See, there is no ownership concept. Don't think about any ownership here. See, what is it I'm doing? OBJ means what I'm doing here. No. Don't do any. No. Don't think of any of that concepts now. You just see what is OBJ. What does OBJ contain? It contains a value that is 12 and 23. So what will I'm trying to pass? The content of that data I'm trying to pass to another person. Correct?
Yes.
Now you just do one thing. So I write down V dot. 1 minute.
Right, because it is not a reference type, it does not, it implements copy. So that is why it does not do move, it does a copy.
It does a copy. Now just see now. So I have not saved this. So now I'll write like this, struct copy. So there is a, you can see that that is not a problem. So I have, my program is having one error. Can you see what is an, silly, I always,
So println also up above.
no, I have no
Vector,
problem.
vector speed will get
Printer doesn't.
Printer does not evaluate to something.
No,
Printer doesn't need a sector.
Okay, that is true.
because macro.
We are not taking an out, like return from it.
Okay, now we'll run this. So what did you get there? The content is received. Correct? OBJ had this value 12 and 23. That what vectors received it, right?
And print after that set
But-
function.
Okay.
So this should not work, right?
Now, okay, let me see how many of you will give me answer. This will work or not work?
This will work.
It is 100% will work.
That is not a reference.
That's no problem.
See,
Sorry. I got one
Warning.
error. Funny, huh?
I think that
Semicolon.
after.
Okay. Okay, so you have optimized your editor with the Rust plugin. Why are you not getting curly down bracket like lines, red lines in VS Code? You should be getting something, la. These are the
Correct.
problems.
Rust analyzer is
Rust analyzer
It is
is not there.
blocked.
Maybe.
Okay.
There is one plugin.
I have also not been able to.
So there, can you see there?
Ownership is mine.
It's smooth. That's what I was.
That's what I was saying.
No, the reason
Yeah.
is no one.
Even I thought.
Yeah, I was.
Wait, wait, wait.
Should not work.
Has
It
to
should
be.
work. No, one. The reason
You gave the same example with string
Correct.
some time back, and that also.
If it was ampersand vector.
No. 1 minute. No.
If you're passing the address, ownership will
Yeah,
not
exactly.
go. You're passing ampersand. But now in this case, ownership will move because you're sort of
One minute, 1 minute. See, I want to clarify one thing here. So regarding this, okay, now you forget about this thing. Now I have moved the content of this to this guy, right?
Yes.
So there is a copy of it. So now what you need to think here is, I said that every memory should have data only uniquely once.
Correct.
Correct or not?
Yes.
So to have the data uniquely once in a memory, what we do is only one copy of data should come. We want to do that only one copy of data. Now if you see here, to ensure that one copy of data, he said that move occurs because OBJ has already vector which doesn't implement copy trait. The reason is, if I do that, then it is different because now it is taking that by default that copy trait and implementing it. Okay. Now one.
Sir, if it does not implement copy trait, that
Hmm.
means it must be a reference type.
Yes, it should be. I should be doing that.
Now.
It is moving now. Now,
Yes.
okay. Now 1 minute. I have one more point here to clarify here. The reason is that I'll give you the concept here. When I will give you this point, I just suppose say you that I'll give you this point because this is little important that I missed out here to tell you. If you write any class, okay, generally in other languages or anything, they will provide you a concept of a copy constructor and assignment operator. Why do they do this? Is when you pass an object by chance the value, what will happen? It will allow you to copy that thing, right? Here, what happens is whenever you are trying to pass an object by value, if you pass any object by value, they will automatically
Pass it by reference.
not pass it by reference. They will automatically move.
Move it.
Okay, move it.
Yes.
Okay.
See, it is similar to what you did.
So what I'm trying to say, it's similar to that. So I missed that point. And one more point, what we need to be very clear here is that the movement of data happens for few things, especially for structures. Okay, and if you are looking for strings, and if you are looking for any not only hash maps, it is also for any box type of memory. For all this, they have
Even for our objects.
For non
for almost
primitive.
most of the objects, they've implemented those internal things.
If it's an integer, will it work or will it
Not like integer, but there are most of the times when you are dealing with the kind of heap memory and all, where there is a complexity. No, it's not. This is not only heap. See, I am trying to tell you.
Is not on heap, sir.
See, in my case, it is not on heap. If I am taking a vector object, which is BEC macro case, then it is different. In this case, it's different.
It would be on a stack and it would be pointing to the
Yes,
read only, right?
yes. So now what we do is, listen. If you want not to allow this operation, we will have to write a derivative.
Yes.
You will write a derivative, and in derivative, you will say all that thing what you don't want to do. If you do that, then it will not do, because I didn't do that. Okay, so that's the reason it has got moved. So, but we will talk about that. If you write on that thing, and then we'll do that operation. So now, so what I would suggest you to do here is, so as I said that, yeah. So what I suggest you to do here is, instead of doing, okay, now you can do one more important concept here. See, we have two important things you should always remember in Rust whenever we are trying to ensuring that in memory segment, any movement of data that we are doing, any moment of data, irrespective it is whichever memory it is, whether it is stack or heap or whatever it is, whatever the specific thing that you're trying to do. So you need to see what are you holding. You should see only what is that object actually holds. What is that actually that object? What is that value it holds? You need to only see. Irrespective of that, if you understand, then it is easy, so that you will not have any challenges. So otherwise, you will have these things. Okay, now what we will do is let's do one more trial. So let's do one thing. Let me return an object. Return type is what?
Vector.
Vector. Okay. And to return an object, what will I do? What should I do here?
Just
I'll
V.
comment
Just
this.
V.
No, I will create an object. Now just I can return the same object,
Yeah,
but if I return the same object, what happens? Again, you will get this. This is again moved to this guy. Okay, so that will be copied to one more person, right? This vector is unnamed object. It's a unnamed object. Guys, generally you have named objects, unnamed objects. When you return something, it is an unnamed object. That unnamed object only you will reference with the return variable name. Okay. So for example, you will be doing like this right here. All right. Let RET is equal to this. RET will point to this guy.
Yes.
In this case, what if I do now this case? This is how I'm trying to write down now. Now I'm trying to write this way code. Now what this case will do?
See, ret is not used and
Uh-huh.
ret now owns
Okay.
OBJ.
Ret will own OBJ
Like
now.
ret. Sorry, OBJ has moved to ret.
Yes, correct.
OBJ has moved to
Object
ret.
which
See now.
object which implements the copy date, then we will not have this problem. Right?
Yes.
So the defined predefined data types like int, float, that doesn't.
Yes.
So those have them implemented
Yes.
already.
So for almost all of them.
So for the primitive data types, it works.
Yeah, I know.
So the central idea is that C, you could do anything. You want to pass the structure, you do it. Tumhari marzi, tumhara.
See, that is for
Can
you
we
say.
implement a copy date for our own user defined data types by simply adding attributes.
You have to add redux. So we'll anyway do that.
So what you have basically implied is that you cannot move structures by full copying, like
Yes.
pass by value. You cannot do it. Even if you try to do it, it is pass by reference.
Even it is like a kind of one person only will.
Only
It's not like a pass by reference. Don't say it's a pass by reference.
Okay.
The content is moved to that one more person,
Okay.
and there's one more copy of stack is allocated.
Ownership will also
But the
come.
previous stack of the memory doesn't have anything.
Then you have to
What is
return it.
borrowing?
Same,
See, borrowing is almost same.
same. Your
Moving that.
ownership is moved
Moved.
right, to a different variable.
You have one. We did that. Let the name is
Yeah, yeah,
equal
yeah.
to.
So in
same
this case
person.
also, like when
Borrowing.
you're passing
Borrowing
a
only.
vector, so who is borrowing it? The function inside.
Function,
Yes.
जो argument में जो है,
This person has borrowed. Vector has borrowed it. V has borrowed it. The content of data is got. He got the content of it. Now again, I have written here vector V, and again I have done this. Now what will happen if I write down now this C? Now again after this, I'm trying to get what?
You're trying to get OBJ.
Now I'll try to write.
OBJ is
No. OBJ is no more there. So what I should write down here?
It should be
RET.
ret. RET.
Now what if I do now RET dot? Now you can see. Now I'll be getting the value.
But there we are just.
No.
Returning-
This V.
What are we returning?
No. This V here is actually a return value which will copy into this, and then this will be referring.
We will be return.
you are taking it and returning it.
See, actually, this is an unnamed object. You can say it's a register memory or something. Also, you can say it's a return type will be stored in register memory. So that memory is getting a copy of this. Moved it to this guy. From there, it is again moved to this RET.
So one very quirky thing about Rust is that you don't need to write retard here.
No. I will give you one more point.
Is it like the last line with the return?
Yeah.
No, last line will be
last
written.
line.
But we don't need to write return keyword here.
Yeah.
We don't
That
need to
line is
add
this.
semicolon. If you want, we can also write.
Yeah. I will tell you.
So the last line,
Yes, sir.
whatever data type is there.
The last line
Don't
is
say
a one line
Evaluated
statement.
value.
That line doesn't need to have a return keyword, and whatever you write, that will return. So if you say semicolon, it's not say semicolon in the last line. If you say semicolon, then it will explicitly say that you want to return something and you have to tell that. So before that one minute. See, one point I would like to tell. No, 1 minute. I will tell you one diagram. This should help you a lot. See, for example, so I'm here. Okay. So generally, the programming style of models, which I'm trying to talk about here. So if you see here, fun1, there is fun2, there is fun3. I'm talking about rest only. Okay. And now carefully listen here. If you call fun is calling fun1. Okay. I'm calling which function? Fun1. If I have a variable a, that a 532 is equal to 5. Okay. Now I am trying to write down here fun2 of a. What happens now?
It does a copy.
It is moving the.
Moving the
Okay. Now, okay, I will ask you. First, we will leave this
No, it's
topic.
not one. It is only a problem.
Just copy.
No.
Integer for a type, it will copy. For the primitive data types, it copies.
Only okay. 1 minute. See, you will forget this copy. First, you listen. You tell me when I'm calling this function. Okay. There is a memory allocated for a, right?
Yes.
It has some address, right? Some stack address. So let's say 4661214. Correct? This is an address. Now inside this address, what is there? Data is 5. Now you call a function. So what if I call a function? Again, here there is a variable a. Again, there is a memory allocated. Again. Now once this memory is allocated, here what will happen? Right. Now this memory also has this data. This memory also has data. Correct. But generally, this is what all languages work. They will give one more stack, they'll allocate one more stack, one more stack. All will have same copies. Or why?
So that this can, like, the
the whole
of FN2 cannot reflect back to FN1 single responsibility.
Not shared memories, sir. So
If
why
you
there's
will
a
pass that
problem?
reference, then it will affect.
it will affect. Otherwise,
Does 5 is it also treated like a string literal, like
no. It's not like
read-only data kind of thing, or no?
it is not like a read-only data, but they want to only have that data only uniquely once only. They want to store that data in the
So
memory.
what will happen in this case now? Because 5.
If you see now 5, I'm trying to pass this 5 to this function. So this data is copied to this memory. Now again, if I have something now, I'll show you this. Now I'll write down here again pass a. Now again, what will happen? Again, there will be one more guy. Again, I'll have to have here. Again, I'll have to store 5. Now what? How many memories of stack you allocated? 3 memories of stack you allocated.
But in string, like we are pointing to a same location.
So in string case, it's different because you are pointing, you are passing the address.
So you're saying that in this case also we are wasting.
In this case, also we are wasting memory where we are trying copying. No. In every language, this is
Including
not such- no. In every language, we are trying to do this. But what I'm trying to say is this uniqueness we can bring. Okay, so what I'm trying to give you this is a problem that we have. Now, just now I passed an object. Correct. So what they're telling is they are very cautious about a memory content of it. What's that? If you don't have the content, you will not allocate memory. They are thinking different way. If we have data, we will think about memory. If data itself is not there, you will not think about allocation of another memory. So they want to do in that approach. Now, what I would suggest you here is, see, anyhow, if you see one point, I'll tell you. In real-time scenario, if you are thinking, we never take any normal variables. Correct? So we will always, the best practice we will do is we will write structures. Correct? And we will, when we write structures, so we will try to always do what? We will write structures and we will try to, if you create an object, you will try to pass that object. But object will be a huge data. So obviously you will whenever you are passing that object, generally the data travels in object. What I'm trying to say now, if you pass whole object, what happens?
It doesn't move.
Again, it is again that, right? So what is the thing is that if you start moving it again, it moves again. It can happen. So what happens to this memory? This memory is no more having that. So what happens? The data is overall in one place. What is the one benefit we will get here is that, generally when you debug code, you will see lot of places same data traveling, right? We keep lot of trace points and just doing it. Now, what is the benefit we will get to know is in your REST traces, if any problems comes, you may figure out exact problem in exact place. You may figure out the exact problem in exact place. You're getting what I'm trying to say?
Yeah.
You will most probably get exact place. This is the idea what I have. This my
Because
learning.
that data will only exist in one place.
Yes.
That's why.
So you will be able to trace it, and it depends upon your support for the organization, and you follow the best practices, may implement that. It is not that if you don't implement that, then you will be into trouble, and that's the thing. Okay, and second point is that if you see the whole point here, what I will do here is I will try to write one more thing.
So Rust will also will just move the A to a different
Yes.
stacks.
Now you can 1 minute. We are already here. So anyway, I'll go for it.
Only trace is a struct it will, right? If it's a
If it is a normal data type, also if you want, you can do that. There is an implementation for that. So I'll just show you.
I have
that.
some two like a bit parallel doubts which are just come.
I will.
Yeah, we'll take it later. Will be better.
Okay.
Write it down.
Now I am writing like this. Let A is equal to 23. I am calling fun1 of A. Okay. Now I am trying to pass here like this. Now if you see here, I am trying to pass the data of A to this guy. Now what if you look at this thing? That Go language style I do. What happened now here? What do you think of it happened here? Okay, I will do one thing.
this will work actually.
This will work, but you can avoid this as well. You can implement your not structure. You can implement the trait and
You can have it similar to
the structure. If you want to implement, you can implement. That I will show you. I'll give you that tomorrow actually. Okay. So if you want to do that, you can do, but it is possible.
it's like to save space.
No space you will not save.
It's not about save. It's
Uniqueness of the data in the
uniqueness of
memory.
the data, we
You can
even for
enforce the uniqueness of the data in the memory. Yes.
even for the primitive data.
See, if you see that whole idea, that there are 3 copies are coming. So 3 copies are coming. So you don't want to have 3 copies. You want to have only 1 copy. You can enforce it. Okay. Now now what I will do here is here what I'll do is if you see now there's another case study we can do. If you see generally a passing reference, that is we all know that is not a challenge for us. That is where we are not focusing about it. Now there is one more challenge here. So what if suppose I am trying to allocate a memory for this in if suppose for this A, okay, I am allocating memory in. I will not do here like this. I will write like this. I will write a value 5. Okay, now I'll pass this B here. Now in this case, what happens? Now B will go, and this guy will be type automatically, right? So what is the type you have 5? Box.
Or it will be int star.
You can write a
Int
int star also. You can
star.
write. No.
I32.
E32. You write
Star
Am-
identity.
star.
Star I size.
I
You need to
size
write
is
a-
different.
No.
Don't use I size.
I size.
I think we need to give different type. No.
I
We
will
have
use
to
this.
write because expected mutable are con. So okay. I am passing here this, so you can. Okay, so you write better this way. Mute.
No, if you say like ampersand, what will happen? Because we are passing the address only, right?
If
We
you
use the
pass
address-
ampersand, then no, it will become the other way what I told. So if you pass ampersand of also, then the address will be.
No, I'm not passing. I'm saying like I'm receiving it as ampersand.
Then we'll have to pass.
If you receive it as an ampersand, then you have to write here also, right?
No, but,
Ampersand.
no, but D is already an address of.
No.
File,
See here, what we are trying to do is, if you B is not already B now it is transferring the ownership. Now if you want to do that, yeah. Now what you will do is I'll write here star. Sorry. See here you can use star mute T. I'll write not T. I will write here I32. Now you. Oh no. You write here you write here.
Box and you have to give T.
T.
T is a
Right,
generic box of
D.
it's a generic type.
Generic type.
A box of I32 also we can. Yeah.
So you can write. We'll write here. See, we have to
Actually, we
write.
are passing pointer to a box. It should be only be a
You
box.
should write box.
Yes.
Star mute is not.
Star mute is not needed. Yes. Now it should.
And ampersand.
Ampersand also should. Yes. So now I'll put the diagram. So guess what I have done now? I'll tell you 1 minute. See. B type is what? B type is box.
So like box is a type. I was
It
thinking
is
box
actually.
is not a type. Box is just a.
Box
want
is
to
a
have something
box is
reduction of a
actually
type.
box is actually you can take it's a generic type where you can pass anything. So if you see here, I'm taking their box and I'm writing what type of it. I32. I32 is the data type I'm doing. So here what happens is this B type is automatically box up. If you want here only you can write. You can write box.
So if we generalize something with box, or if we initialize something with box, then whenever we are passing it, we have to pass it as box.
Yes. So if we have to do that way, but generally I'll try to put this diagram also. Say if you write down box population new, what I passed there is 5. So if you see the 5 is allocated somewhere in memory, right? Now B is actually what I'm trying to pass. The definition is moved automatically to A. Now A is the owner kind of a person, right? Now once I do this again, I will not be able to access. Now there's one thing here. Okay. So what you can do here is, if you want, in this case, what I've done here, the memory is okay. Is the data is going to be unique here?
Yes.
Correct?
Yes.
Data is going to be unique, right? If data is going to change, the data is going to be unique.
It's going to be unique.
Data is going to be unique. But what is that changing here?
But there is no change.
No, there is a change.
You're talking about the copy from 5.
No. Actually, the owner of a person is the owner of the person was B, who was pointing to that memory. Is now is A. A is the owner of that person, which is pointing to that memory address location. You can see now. Now, what you can do here, one more thing. When you are using box, if you want a dereference, so how you can dereference? You can write B also. It will automatically dereference. You can write star also. Star also you can do. B also you can do that. So you can dereference operator you can use here.
Is there a visualizer tool for this memory? Like
There is one visualizer way. I will tell you.
this memory model is a bit hard to be
This
tracked.
one is no. What I will do in memory is I will simplify 1 minute.
not drawing.
Code,
Like, is there a like web tool for this for Rust? Like, so like when I was learning C, like I come from a Java background, like school days Java tha. So
it will take the same thing. If you write ampersand,
So
no, in this case, if you write B, you are only giving the definition of that thing.
No. And his question is like, when we, the function expect the address,
Okay.
and when we pass, while calling the function, we are giving the address, then it will work. And we are doing that. So what I have done is, so in FN1, I changed the signature to ampersand and I passed box of view 5, ampersand of box.
Okay, I'll tell you what you have done. No, I have done what you have done is you have allocated a memory, okay, and in heap, and you are writing ampersand. So what is the meaning of it? If you have allocated memory, already there is memory allocated, and that address is stored in some object. Correct, right? And that address of it, what you are referring. You are understanding what I'm trying to say. You are, if you remove that ampersand, then this will not work. Then again you have to collect with again box type of it.
Got it.
So if you are from a background here, you are from Go background, right? So if you are from a background here, always remember this concept. So you can always write here in your fundamental things here. When you create an object, how do you guys create here? So how do you create an object here? If the structure name is data core, so you will write just a data core and flower bracket, correct? But listen carefully. You can also write here ampersand symbol. If you write, this is commonly in Go also same process. If you write here ampersand means what? You are passing the address of that object. You are passing the address of that object. So when you pass that object address of it, that object, then you will collect with a pointer. Huh? No heap where it's an object. No heap. Don't. If I use new only, if I use new only, it is heap. Otherwise, it is not heap. You. If you want another approach is there, what you can write ampersand, and again you can write a box scope position new, and you can pass like this. So he did that style. So this diagram, if you can understand, box scope position new means what? He is actually allocating in heap. 5 is allocated in heap. So what he is telling is that address. So that now this is allocated in heap. Again, you are writing here ampersand. Ampersand symbol means again you have to create. It means see how do we tell you? Okay, let me put this way. So in you can write like this. Let x is equal to ampersand 5. What is it? If you write like this, let x is equal to ampersand 5.
X is having the address of
this one line. First 5 will get some memory and have some address, and again x will have some memory. Again store this address. That one line looks like one line, but it's not one line. It is 2 memory allocations. So that is where this kind of tricky coding. This kind of tricky coding we do more in Actix Web Framework. We do a lot like this, and that's one among them. Okay, now we will just go to the other part. Okay, so that's, I think this is clear. I think you can refer that person. So he is showed that vector population new and vector that's it's possible. So whenever you write like this, so you can see this methods. So can you see what is this I'm writing here? Vector population new is a what is that I'm trying to call, and that guy will allocate memory for me, right? So when to allocate memory, I should pass type or not data, because whatever data I pass, it will automatically identify type. I should pass some data, guys. If you pass data only, it automatically identifies type. If I don't pass type, I said already, Rust is a type interface language. If you give data also, it can identify. It can do static typing, dynamic typing. Static means you can write manually, type and do. Otherwise, dynamic typing means you have to give data and then it will do it. Is this clear what I'm trying to say? Okay. So I'm that at this point the compiler doesn't know exact type of vector, but it just knows it's a vector of something. So vector of something. So that is generic. So that is what it is all about generic. So it is a generic type actually here. Okay. And now I call this which method? Push method. If I call push, what happens? You are actually passing some data. Now it will know the type is U8. So this I have put it, that's called interface, inference, sorry, inference. Inference is automatically understanding your types.
So sir, the allocation happens after the push method call?
Initially, when you write this line, it will not know the type and size. So it will hold that length is 0 or something it will store. Okay. When you do push, what happens? Now only actually it's allocating in heap.
Sort
It
of
will
like a
allocate.
lazy initialization.
No, it's not. It's a kind of thing because
like
this is a
functional one.
general stuff we do it in almost in even any language background. When you are doing it, we do that because we first do allocation, memory allocation. We cannot at least tell type. Sometimes we don't tell type. Here we are not even telling type.
That's also not the right way, right? Like,
No, we will correctly we have to tell type. And
so that by mistake, sometimes what happens? Like we might return a different type from a function, which is not expected.
so we should always implement that as well. So we will do that. Okay. So I will talk about this guy. This is the trait, dynamic trait we have, and I told you vtable.
C++.
Vtable VPTR. So this is a call for tomorrow. Reminder, like chapter 1 to chapter 2. So reminder I'm being.
So we'll revise
This is a very interesting thing. Tomorrow it will come. So that is where you will have all this method, size, align, all this internal. So whatever we discuss, we'll discuss that. That's not a problem. So now let's move on to the other agenda.
What's the identifier to print the type?
Sorry.
What's the identifier? We can pass in print the type.
You can also see there is a method, there is a library method. We will use it to print the type. You have to use a package. Using the package, we will do it. Okay, now what we'll do is, guys, now I want you to open, there's a file with you, please. So before this, you open this code examples. Day 1 is there. Day 1, day 2 is there with you. So can you open that day 1, day 2?
Should we take a break of 5 minutes?
Okay.
Yeah. Okay, so now I'll ask my weird doubt.
From that, I think is with you guys. Doc.ref.lang. Is that right?
Yes.
So in this, if you go, you can go to ownership. So the diagram that we discussed about, the whole thing that we discussed in the diagram has been explained there. So if you go scroll down there, so there is a question that even Sai was asking it, that can I do like this? What is this? String scopulation.
Yes.
Yeah. Tell me, Sai.
No, yeah, that's the same thing I'm asking, like,
Yeah.
which
The
is
question-
better, string from or the
question-
other way, like two string?
Yeah, definitely. It's a good question. So when you write like this question, and there was also a question from Sai that it was also that if you write like this, So this was the one we were learning, right? So what is the difference? He was asking, and the reason is that this rest is there. Before that, I'll tell this guy. Then this is easy. So we'll first talk about this guy. Okay, this is a line we are talking about, right? So what happens is you are passing hello. So hello is passed. It's like a slice, which is passed. Okay, and he will have this slice, and he will return you string object. You are passing a slice, and he returns you what? String object. So that string object can call push, because string object can extend, but this hello cannot be extendable. Hello is stored in read only.
Okay.
So generally in all the, he was asking, this is a preferred approach.
I think that is because you used mute as well, right?
It's not that this is, no, this S is a string object. String object is mutable. You can extend it. No? To extend it, you have to use
If you
mutable.
don't use that.
If you don't use that, then you cannot push. You cannot add data. No. So this one we already know. And second thing, if you see this diagram, he also asked one more question: why it is allocating 24 bytes of memory? Which one? If you see, he is also asked one more good question, that so why your program? If you run this program, if you can use this program because he is using that namespace. That's it.
You can use triple finger up.
That's okay. I will. Okay. So if you see there here, the memory size, the memory size of this str1 will be more than compared to str1 and str2 both will give you same because in this case it's both of them in this case same. I think 1 minute.
Because we are passing and str.
Yeah. So I'll not anyhow 1 is fine. We'll keep the 1%.
In the println, this should be
Println,
And exclamatory is yes. Okay, anything else? Okay. Now you can see this. Why is this reason this token?
Oh, okay. That's a different Unicode kind of space. Sai, can you paste it in
No,
GitHub
it's
gist
okay,
or
it's okay.
something?
Yeah, remove.
No, because the same space will be there for
Yes,
everywhere.
everywhere.
No, everywhere it is.
So,
there.
okay.
Wait. Remove.
You can.
I have removed.
Focus. Sai, can you paste this in GitHub gist if you have or on laptop?
Yeah, I'm on laptop.
So there are like different types of spaces in Unicode, and this is not ASCII. Or if you have MS-DOS to Win in your system, you can convert it.
Harsh, it will done. Okay.
It's not done, no?
Yeah, I will do it. Harsh, I will do it.
Okay, no worries. Ab ho gaya.
There's between the
Yeah, that is okay. That should not be a problem. Okay, so you can see here the size is 24 bytes. Which is the size is 24 bytes. So the question is asking is why this str1 is taking 24 bytes, right? We all know the answer. What is the answer? Because there is a pointer, length and capacity. Correct. So if you see there, mem copulation size of val, mem is that whatever module we are accessing. So inside that module, there's a function size of that you're calling, and you're passing this. So when you pass this, it is giving you that thing.
right. So he's passing the address of that, right?
He's passing the address.
If you remove ampersand, what happens?
No, if you remove ampersand, you are giving ownership thing.
Oh, okay. You didn't print the value.
No, you are asking the size of it, and you are mourning the ownership. That won't be anything. But generally, you are supposed to pass the address on.
How can I get like the strlen equivalent
No,
of?
if you see here,
Oh,
no, they have made it as reference only. It means in the syntax of that documentation, they are expecting reference only. So we should not because it's a library function. It's not our code, so we will do that. And
So what's the difference between toString and from?
see a toString. That's what I would like. So now this Rust, this is a string. This scope of this memory is a compile time memory, and this Rust is accessible from this scope to this scope. It is till end of that main
lifetime.
Lifetime is that because you can access this Rust till end of this, right? But if you see that guy, which is this guy, if you see this guy, what happens is you are passing hello. Hello is only visible to that from function.
Okay.
It is not visible to main also.
It's not visible in RO data also.
It is a function call, na? It is this function call data. What you are passing is only visible to this function. It is not visible to anyone. So that is why they prefer this.
This is better.
This is better one. So this is the one. So you can go to this diagram, please. So if you see this diagram, can you see the diagram, please? Because this diagram we've already discussed it in day one. There is a pointer pointing to that string, and there is a length and capacity which is having you 5. So that's 5 and 5. We are trying to store that, and this is information that you can see. Okay, this is the information. If you are moving it, what happens? If you want, you can also make it a copy of it. Also, if you are doing it, see the representation in the memory. Yes, to the copy of the pointer. If you want to do that, what happens?
This is a clone.
If you are doing it, if you want to do it, If you want to assign, when you assign, what happens? So this guy, the representation, you can see that that's where you can see this representation. If you want, generally this is also possible. But generally, this is again too much complication. Memory should be always unique. So you are trying to copy a deep copy only. So memory should be what? Unique. So the data should be unique in a memory. So if you are again keeping the same data in a memory, it's a duplication of memory. Why you want to do this? So if you want, you can do that. Now see the another possible. If you write down now this one you cannot. This one you can. If you want to do that, you can borrow. If you do this, see this is what you are doing. Now see now what I'm doing. Other possibility is this. So now see S2 is equal to S1. So this is if this one minute. I think he's giving. Is giving. I think correct time. I think he has 10. Okay, first he has written he has used their string dot from hello. He has used string dot from hello. So what happened there? The string, no, he is not using that approach. We were writing hello dot this approach. So what happened now here? Hello has happened. So when I write S1, S2 is equal to S1. In this case, this way. See now this point is pointing this way. Now if I write down here, you see that. So if you see that there's a pointer pointing that thing and capacity. Now this is representation. Now if you write down S1, if you write down something like S, the representation S2 as a copy of the pointer, which if you want, you can do this. When we assign S1 to S2, the string data is again copied, meaning that we copy the pointer length and then the capacity are in stack. We don't copy the data on the heap. They are pointing to same memory.
But S1 will become.
No. In this case, if you are doing it, S1 and S2 will point to.
This is
same
just
thing.
like they are showing through the diagram, but if you go.
If you see there's no.
paragraph, you read the paragraph. Then
No.
it says
Yeah.
not doing
Scroll up a little bit. Like we like S2 was like equals to S1, right? It was not like
You
past
No,
read
no.
this paragraph.
No, what is?
Sir, if you
It says-
scroll down little bit more, it will say that S2, S1 will become unusable. It will do a move.
It's the
This is
showing-
automatically should be more 1 minute.
No, it's just showing by diagram the language, previous language, how they did.
Oh, okay. So he's showing that way. So okay, it is like he's telling about the copy, like copy constructor. No. In C++ also we have two objects pointing to same memory. Okay. So then this is I think which is they are trying to make this S2 is equal to S1 is that rest is copied the heap data. So it's, no, don't do that. Generally we point to that same memory. I think diagram presentation you don't take it more in depth, but I have already given it now so that you take it up. So I got this reference to show this diagram. That's it. So not anything else. So you follow the same thing. We said right, it was pointing this memory. And again, S2 also points to the same memory. S1 is no more pointing to S2. Okay. Okay. Now see this is what we do it right. Now what we will do here is not this one. So this is what he is trying to say invalidation. So he is doing that. So if you want, you can do here clone. What you can do? You can do that. So what will happen if you do clone? You will get a copy, a deep copy. You can do that deep copy if you want to do that. So you can do that clone. Okay. So before this, before this, we will move on to our thing. So anyhow, you restrict to the diagram. So anyhow, I'll just show the diagram. But now we will move to. Can you open, please? Can you open the? I refer that book. Maybe you can refer it. Before that, I have refer. I was reading. I will just share you one more article. I'll just share you one more link. Actually, that's where you start everything from C. If you know C, you can learn rest from C. If you're not from C background, not from Go, it's not there. But it's an article is on completely at C. I will just share that link. I have in my thing. He has explained C to rest. So that's how I learned C to rest. Okay.
Very good for me also.
C to rest. Okay. Okay. Now we will, as of now, let's now all remove the references. See, before this, I will tell you afternoon something important, but before this, I will try to simplify. I am ensuring that I try to simplify. So please go to that code examples. Can you go to day 1, day 2, day 3, day 4, day 5, day 6, day 1, day 2, day 3, 1.1 data types is there. Okay.
Data types,
Hmm.
1.1 data types.
Okay. So if you look at the whole concept here, so the first one, what I've written here is the first example, I guess. So I don't want to talk much about it, but anyway, you know this thing. There is one question I will ask you. How much memory? Okay. Before this question, main is a function, correct? Main, in Rust, there is one interesting thing you have to learn. Generally, if you see the legacy, if you write a function, if you declare all variables, a function also consumes memory, right?
Yes.
So I will tell you one interesting topic here. So guys, here you see here. See, I try to tell you this internal thing. Okay, if you write one function, okay, if you declare any variable, let's say what is a variable I've written? Let mutable, okay, is equal to 12. Now this variable allocates how much memory? I32 times. So how many bytes? 4 bytes only, right? So 4 bytes. Okay. Now generally what happens is, listen, this is important. If you write a function inside this, what happens is every function will default allocate a memory size of 80 bytes. It will reserve 80 bytes of stack memory. Which one? Every function
stack.
Because it will reserve that 80 bytes of memory, because it will ensure that, because I'm not sure if you are knowing the internal thing, when from here to here, Rust also generates an assembly code. For that code, it generates an assembly code. Are you getting what I'm trying to say?
Assembly
It will
code
generate an assembly code.
Will come for every language.
Yes. So that assembly code, along with this, it will have some registers and all that, you leave it. But generally, when your program executes, let's say this main function is executing, okay, it will be supplied with some address.
Right.
Who will give? Process will inject some address. Correct? So from that starting memory address, your Rust compiler will trace everything. So because it is not only tracing your code, it is also tracking the entire memory space of your code. It is tracking. See, for example, I am writing here let mutable is equal to something. I'll call one more function, fun1. If I do this, what will happen? Anyone tell me what happens here? No. It will generally, what happens is a process will give some stack address. Okay, it will give to this main. Okay, so what? Let's say this address is 6643214. Okay, it will give you this address. So from this address, the code that you have written, how many variables you have written, it will calculate the memory size. Come on, it will calculate the memory size. And from this address, it will minus that memory size. How much will come? Let's say 80 bytes you are taking. Suppose your code has 80 bytes. From this address, 80 bytes, if you remove, then that address is ownership by this main. Fun1, if you call, what happened? The remaining address is there, na? 166.432 minus 80 is some 166.4 280 is something.
100.
This 280 address will be going to Fun1. Then again, Fun1 will do same step. It will take it and it will do this operation. So this way, they are able to track every piece of memory.
So,
This you are calling in compile time.
It is every piece of memory that your code consumes in stack and heap. It is also data segment. He will track everything. He will not leave anything.
Okay. But this is being done by all programming languages, I believe.
This is being run in every language. But if you see traditionally in C and C++,
The stack size
their
is the same.
stack size, no, the addresses where be very happy that they were, if you call this, they will take the starting address and they will consume some memory. Defaultly, they were consuming. If you write an empty function also, it will consume some memory, 60 bytes or 40 bytes, I don't remember. It will consume some stack for them. But Rust is not like that. It will not even based memory. It is very effective in terms of distributing memory, in terms of what you are trying to do.
And
also,
we can't override that with some flags.
it's no, you cannot do that. But they have taken care of that very effectively here. In that is the reason.
So they'll do the math.
Yes, they'll do that. So another important thing is, you all know, when you end the function, generally in languages like C++ and all, it will call destructor. It means the compiler will write code. Who will write the code?
Compiler.
Here in Rust, the compiler writes lot of code internally for all your programs. That is true. So I will show you that. My other laptop, I will try to bring a fifth and show you how that I've checked long back, like how that internally codes that they are writing. Yes, so they were writing a lot of things actually. So that internal code they'll write. So that is the thing. But you can also do that. You can also go to the compiler level and do optimization also if you want. That is a specialty because it is open source. So you can do that math as well, and that is a specialty about it. Then I'm talking about next important topic. Now, why I'm going to talk about this is your mind has some confusion. See, in my mindset, I try to keep all the things in one way of understanding. So in your mindset, you will keep in one way of understanding. So I'll give you one simple clarification. Generally, a language consists of what? Variables, objects. What else? Variables, objects. Objects, how many types? Generally, objects to some heap of data structure objects. Come on, yes. Right? Data structure objects, normal objects, and what? Variables. Then anything else you think generally language consists? Just apart from this. Then we'll have arrays. You talk about only language. So I'll try to simplify that way. It's easy for you to understand. Variables, objects, then data structure objects, then.
What are you asking? Language?
No, I'm telling the type of variables that you do in a language. Okay. So I'll talk. Okay, array. Okay. It is also no. It's a data structure, but generally you are talking about normal. I'm talking normal array, which is fixed size, not a growable thing. Okay. Then what are the other things?
They are in data structure.
No, that will come in data structure. Okay. Then variables, then functions. No, functions are not one. Huh?
Loops.
No, loops you leave it. Then loops, no need.
Loop.
You leave pointer references. I'm not talking about that. Okay, wait, let me put it from your Go perspective. So you will have very normal variables, correct?
Yes.
And you will have a array. You will have a slice. You will have a map. And you have array, slice, map.
Dynamic typing.
Then you have a channel. You have a structure also. But I'm saying there is an object. Structure, I'm only telling the memory allocation. What do you leave it? Concepts of class, function, that I'm not talking. I'm only final is object. Because that is important in Rust. We will have challenge in there only. Object is the final part. Okay, then what else is there? Apart from this, we can also create pointers, different types of pointer to array, pointer. This you can do. Now my question is, if you have all this stuff, if you have all the same things here also, so what happens here is, coming to first variable, here also variable. How many ways of variable you can do? Generally, we'll take pass by value, pass by address. Generally, we'll say pass by value, pass by address. Correct? Yes. Array, how you can pass?
Reference. That's
generally how we pass in array, sir. We can pass by value also. We can pass by reference also. Address also we can pass. But it should be passed by reference. Okay, very good. Slice. It is also passed by value. It means if you copy the same thing, if you want, you can do. But if you want to pass by reference also, you can pass. Okay. So map also the same thing. You are copying by pass by value only. Channel map, all object. So if you, it's a choice of a programmer. When you have an object, what do? You will pass by value or you'll pass by reference.
Normally, a channel use case will always require a reference yourself, because channels, you always want to share a channel.
Channel doesn't need reference. Channel is an object. You are creating an object to channel. So you will write like this: where obj is equal to make of channel integer. So you will write here chan integer. So this chan integer means obj is an object, not variable. Okay, this is an object. You don't say it's a variable. It is an object. Okay, now why I'm talking about this. Now I'm trying to map. No, why I'm telling you this is you have all this in your mindset. Okay, you all have worked on this, so you know how to pass them or how to not to pass. Now just give me a conclusion. This mapping I'll do it here, then it is easy for you to understand. Now
Side is just.
this is rest sir, this is Go. Or you can put it any language. Okay. Now variable, how you can pass?
By reference.
By value you can pass, by reference you can pass.
Reference means address.
We can
And
take a
separate.
references. That's what you can say address. Correct? Next objects, how you can pass?
You can
Objects by pass a value you cannot do.
Compiler error.
Not error. It means compiler. This is a point I'm trying to say is this enforcement of a compiler that passing by value is an enforcement.
Reference.
Passing by value, sir. If you pass value, data gets
Data move.
one mode. It means only one owner. What is that? One owner.
So they can pass.
We can, if you want, you can pass.
Can pass.
We have to implement
But
something
then
and
we are
pass.
moving.
Yes,
We are losing ownership.
yes, we are losing the ownership and we are moving that thing.
We can pass that by using dot q.
Yes,
So it is wrong to say that we are doing pass by value. We are not actually creating another copy of the object. So it is not pass by value by any means.
you can even say that it is like, you can also say that it's, instead of saying pass a value, more of it you can tell also that is that one copy of data.
Yes, only one
It's
copy
better
of the
telling
data.
the unique data.
We have shifted it somewhere.
You can say it's a unique data.
Can we just think of it in loose terms, like we are passing a message? Like, can we think of it in that way to simplify
You
things?
think of it that way also. No problem.
Okay,
No, you
because-
want to think, you understand. You see,
Uh,
you need to have understanding. I have one understanding. Your and terminology, you need to map it. Then you have no confusions.
Save this for all the variables. I mean, for all the.
In the same case, if you see it, the whole complication simplification is that all data structure is an object here in REST. Array is also a concept of object here. Maybe I don't call it as variable. I call it as a object only. So even normal objects is also object. Now all these objects, how do you choose to do it? What do you choose to do it?
Reference only.
So that is the only choice you have to think here.
So like, what's the use case based on that, right? Like,
It is also a
do you want to keep the ownership with the caller,
Yes.
or do you want to delegate the ownership to the called function? So based on that, we have to choose.
your point is exactly correct. What I'm trying to say, but I want to clarify something on the same point. Okay, so if this is the problem, if this is the design of a language REST, okay, now you come to case of what library. If now, for example, carefully listen. This is where I'm trying to give you a clarification. There are two choices here. You become a owner, or the library become a owner. So what do you do? What do you think of it to become? You want to make him owner?
We want to do
You want to be owner? Okay. But he wants to be also owner. He doesn't want to be. Why he wants? If he wants to be owner, what he will do?
we want to transform.
He will give you. He will ask you to collect it by slice or something. He will ask you to do that. It means what I'm trying to give you a clarity is when you are working in the real time. So I'm telling you this mindset. Then language, he told me one thing, Venkatesh told some no. When you are working in real time, the concept from language and the concept to framework or library will switch. It means that the ownership will be taken by him most of the times. Or sometimes you will be the owner, you will give him that, or sometimes what happens is he will be the owner, he will give you an access by giving that slice. So just an example that we have written now, string scope relation from, and we passed what? We passed data called what? JVT we passed, correct? So what happened is this data is, for this data JVT, who has allocated memory? No, boss. That library has allocated,
Yeah,
boss.
from
Right.
we have given data.
So I am trying to give you that clarity. Again, in language and framework, lot of things comes into picture. So that time you should not take in mindset that one mindset of your understanding you map. Okay. So if you write string dot from JVT if I pass, he will allocate for this JVT, and he will give you that. You will write some object. This object is the one who is pointing to that ownership. Correct? He is pointing to that ownership. Now this object is whose object? You only, no? You are the owner of this, right? Yeah, that is your thing. Now you can call that push function and you can do anything. Now you are a owner, but actually allocation who has done? REST has done. Framework library has done. Allocation he has done. But you are only pointing that allocation. It means now what you have to do is in your mindset, make it in a diagram of a mindset. Memory data sitting in the memory. Okay, and pointing to that memory. So if you put this diagram in your mindset, this is done by, let's assume, library. This is done by you. Are you getting?
So all operations are done on the reference and never on the.
It is not. I cannot say that every time it is like that.
Allocation is never done more than once.
It is not like every time is like that. It depends. But there are some libraries. See, the reason is that we all know that a library designs are done by a lot of open source enthusiastic people. You know that. Even REST was developed by a lot of people who wants to work on REST. They just developed this library, and the prototype. What is that? The prototype of that function, how they implemented, what they implemented, that person, how it is implemented. It depends upon his ability, and we will follow him and do it. We cannot change that design. So it means now what we will start doing is, tomorrow that we are going to do it. So before we do that, this mapping is something that we have to be very sure about it. It means we will start working only with the documentation. So how many of you have referred the documentation?
Of REST.
Library documentation. So we don't, I think we generally sometimes we don't refer sometime, and we do that, right? But I'm telling you very proficiently, I'm telling to your later also, before you all work on the projects, try to work most of the libraries. Try to work with most of the libraries. You would have worked with language, fantastic, but your utilization of language learning to framework or library will be only 30%. Only 70% something different is there. Okay.
You mean to say we use standard library or read the standard library code?
Not standard library reading it. There are so many libraries. You need to see one library, because in one library, the way you execute or design of the program flow will change. I will tell you what is the design of the program flow, how will it change it. So you will have a different scenarios from here and there. There's a lot of difference. So you have to be very clear about that. And as I told you here, if you will see these topics, anyhow, this is not going to be a challenge for us. But there is one more catch that we have to understand here. What is that catch we have to understand here is, okay, now listen, I will, before this, I talk about this, I will write a diagram and show you, okay. So this diagram is, please listen. See, what I'm trying to give you an example is, heap memory, correct? Okay. Now my question in heap is, how many data structures we generally do? What are the data structures we generally do? What are the data structures we have? No. You all the thing. You tell the basic data structure. You tell sir.
Linked list, array.
We all know it. No?
Tree.
Okay. Now listen. Let's say you take. We will take now vector only. Vector, and we'll take only one more pattern called what? HashMap. Okay. There are a lot of things. We have hash set. We have. So you can also do linked list. There is a lot of things we can do it. Okay. Now, so why I have taken this is there is a reason. So you tell me one thing. If you take a vector, inside a vector, now I will try to tell you one small information. Okay. So what is that information you need to understand here is, see, for example, you take a vector or you take anything. Okay. What is your need is that you want to grow this memory, correct? What do you want to do? you want to grow, right? So let's say you had a data called hello, and again I want to grow it, right? So what is the problem we have here?
It is not going to be, might not find continuous memory and then have to allocate new memory and make a malloc call to OS.
No. That okay, that is perfect. So if you create a vector and if you write push and if you pass something, what happens every time it will copy this to some memory and it will do that. Okay, this is one thing. And if you say HashMap, what happens? In HashMap also there will be linked list, right?
Yeah.
Correct or not? So you'll have like this.
Last HashMap is made of linked list.
HashMap is a kind of key value. A key value also will have a key will point to an again array. From that array it will point to value only. But I'm trying to say that linked list is almost the same what we do here. Okay. So if you see a linked list concept as well here. So if you see this is a diagram we write, right? Is this diagram correct? First of all,
Linked list.
this diagram is correct.
Doubly linked list.
Is this the diagram correct?
Missing.
Okay. Generally, this is a diagram they show. Is the diagram correct?
Yes. No.
For HashMap, no.
No. Isn't the diagram correct?
No.
Generally, I will tell you answer. This is the diagram that all books writes, right? But actually, it is not correct diagram. Why? See, let's say this is an address. I will put here this address, and this guy will have which address? This address, but he will show here.
That's what it has to be like.
It has to be like this, but none of the books writes like this. If you tell this, you are selected entry. So generally, I'm telling it has to be like this, but generally this is an address, and you will have to write like this. Correct. So if you are working with HashMap, in HashMap for each key and value, you will allocate a memory. It is going to be managed that memory effectiveness, right? So in this case, HashMap has not got much challenges, but anyhow, you are going to allocate memory for your data and like this. Let's say you want to store here. I don't store. I'll store here one, and I don't have something. I'll put null or whatever it is. This is the two important things. Now, generally, we will do one small conclusion here. If you ask me one question here, this data is allocated in heap, correct? Now, if I want to do any logic, so what generally we can do? What is the kind of logic we do generally? We have a data in heap. What is the possibility we have?
If I want to sort this data.
If you want to sort or some logic you have to do, what will be the possibility? There are what we generally do is we will not copy it, but generally if you are from a language like Go, so you'll be writing like this, na? For I range of something, or you can write I comma v colon equal to range of something. So what you do is you try to copy it.
Yeah, I mean, it will assign.
No, boss, this H is in heap, boss. You copy this content to stack, boss.
Correct. For each iteration.
For each iteration, you copy, boss.
One item will be copied.
Correct. Yes. Are you getting what I'm trying to say, na? Okay. So it means you will write like this. For I comma p colon is equal. Even here also we can write. We can write in rest also. We can write in that if you have a vector, you can write vector dot length. What is that? Vector dot length, and I will get this. So generally, what we have to do here is, so we have that approach, okay. But what I'm trying to say is, if you have this data which is there in memory, is it a good way to copy? If I copy, what will happen?
So it is a good idea to copy because we are accessing a shared memory, right? So if we don't copy and this memory is somehow changed, then we get a restart.
You know the concept of rest ownership, na?
Oh, okay.
Then you have just not 2 3 1 key.
It is just one unique data set.
That's why I'm telling. After you had a fresh key, I'm thinking you are here.
Okay.
You are not here. This is joking. Now think of it. This problem, how we can solve. You know the answer. They will not copy it. They will use references to that memory. We are using more references to this memory. Come on, guys.
So giving data to loop is giving ownership to loop also.
Obviously, right?
Yeah.
This question, this problem you will get. Even when I write code, you'll start getting it. Are you getting now what I'm trying to get it the exact problem? You will get this problem. This problem you didn't get in other languages. You will get here. You will
Over this problem is there, you have to pin
oh,
the
yeah.
data.
You will copy.
Yes. No, but sir, you have to pin it in the loop. Otherwise,
Oh yeah, you will copy.
yes.
Copy means
Oh.
what? Oh, no problem.
Value, pass by value.
Class by value. You will copy that heap to stack.
You mean to say that if we run this loop as it is,
Hmm.
and if that was a variable called a, after that I can't access that.
Yeah, obviously, because this data will be lost in the ownership concept. If I do that, this all H will be coming to this guy. Every time this, if I go back again after running a loop, I go back. That's why they've used that iterator concept here.
Yes.
That's why they've introduced that you will use that iterator, and that iterator will get a clone of it sometimes.
We can do
And you can, that's a reference also you can do.
we can
Reference
use
also you can
iterator.
do, or iterator concept also you can use. So that you will not have any challenge. So for that they'll use some syntaxes. I've also seen syntax, little tricky little come. I'll also show that syntaxes. But anyway, that problem will come here. So this is a whole summarization. So is this easy now, or you are feeling a little difficult now also? Any difficulty you are feeling now also?
We'll get some more like clarity when we start writing code and ID and compilers yell at us.
So we will see now. In next, we'll try to run a lot of programs, and we will try to see that as well. Okay, so that programs are there with you.
You says while you are writing the vector of then whatever it is, you said that it will be copied from stack. So the actual object for that object being iterated is there in the stack only, right? And that is pointing to the heap where the data is stored.
See, this vector dot length I can use it only when there is an array.
Right.
If I have an array, and that array has lot of values, correct. So the value of that array, I'm trying to copy it. That I can do it. I have no problem. In Rust also. Okay. But what I'm trying to say is, if you have the data in your data structure object, it's heap only, but it's a data structure object. So when you run a loop and if you try to take a copy, then the problem of ownership will come, right? That time what we have to do is we have to use a reference, or we have to use an iterator. So we will not use that approach. We will use here iterator, and we will use that concept, and we will try to do it. So anyhow, we'll see that. Anyhow,
If we are traversing through the loop and somewhat we travel only half the loop, and then we try to access the variable. So would we get the later half of that variable or
the later, because we are in the middle, because every reference will point to that memory only. It doesn't know the previous reference. It is overwritten, na? So it is only pointing to that guy. So the reference is pointing to which memory, that memory only you can access.
We'll get compilation error, right?
because
Obviously, if
So
you are
running of the loop is not in.
running of the loop is not, first of all, if you see in your case, it is your program will automatically throw you a panic. Okay, it will automatically throw you panic. See, you will get this problem when you may not get this. You may not get this problem because if you are using an array, and if you are having an index, in that case you can iterate, and when you don't have this length of it, then it will stop, and then you will do a panic. But you may not get this problem in your heap memory thing, because you have to implement that logic like that. Okay, so now we will get into the things. So if you can open that program space. Okay, have you opened that files day 1? So I am done with this. You know this program, so I don't want to explain this. The first program 1.1 data type.rs. Okay, so the second one, can you see the second program? Guys, 1.1 data type.rs. Click on that, guys. Okay, did you click on that, guys?
Yes.
So in that example, let mutable is equal to 1, correct? So this is a variable declaration, data types, correct? So even 1.2 is also basic variable data types. So you know, right? I already explained it. 1 byte consumes how much memory?
8 bits.
8 bits. So what is the maximum value?
255.
If it is unsigned, it is 255.
Yeah.
If it is signed, it is 127 only.
127.
So if you try to put it, it will overflow automatically to 0. That's an example demonstrated. Okay. So you know how printing and all works. It's all simple there. Correct? You can see that. I will not run in this program. There's no use of that running. So go to 1.3. Okay. Now here is a concept of enum. So I will talk about this. So before we talk about enum, so you know enum is existing in C and C++. Correct?
Yeah.
So what is the use of enum? Why we use enum? What is the use of enum and why we use enum?
Mostly like a macro only, sir.
It's not a macro.
But it's a nice way to
Okay.
assign some constants of a specific type, like,
Specific type. Yeah.
Okay.
and they can be referenced from 0 to n minus 1 index. Like,
So this is syntax of enum. So inside the syntax of enum, you will write like this something. Generally, we have to write capital letters. So you can write also small letters. So a variable type can be enum.
yes.
Why we should write a variable type enum? Trust me, in your code, you will in your company, if you have worked here, you would have written a lot of enums. Why is because in your storage device, for all your errors or for all your requests, you would have used enum. Okay, so listen. So I have written an enum. The enum name is data core. Yes or no, guys?
Yes.
So how to if I write a variable name, let JVT colon data core. So what if I write data core here? The variable type is what?
Data core.
So what if I write like this? What happens? What do you mean by that? The value this variable has to be assigned either 0 or either 1. You can assign only a value 0 or you can assign a value 1. You cannot have anything more than that. Generally, what all the developers will do, listen carefully. In your code, lot of times you will be writing a i32 variable, but you will never be assigning that big size of data.
Right.
And you know what happens? You will write i32, but what will developer or programmer will think is I can assign the huge data of thing, right? So that is where we don't want to unnecessarily waste memory. Now, how much memory a enum takes here?
It should actually take the
1 byte. No, it will also take 4 bytes.
4 bytes, because for CPUs, it's easier to read 4 bytes together.
Yes,
than,
faster.
Yeah.
Then you are talking about structure padding, right?
Yeah.
So that happens in here also. Rest also it happens.
So
If you write a structure, in that also it
technically the
happens.
CPU can't even read 1 byte.
Yeah, I will tell you
It will
that
read
later.
4 bytes and then it will zero it the last 3 bytes and then it will give it to you.
No, that structure padding and all, I will tell you now only if you want to understand it. Okay. So pay attention, guys. Okay. I'll write a structure. Inside that structure name called code. Inside the structure, I will return a variable I, which is of 8. What type? I8. And there is a variable J, which is of type I32. There is a variable called D, which is of type I8. You know what compiler will do? It will first see I8, allocate 1 byte. It will see next is who?
4 bytes.
Integer. He needs 4 bytes. Now he will think of adding 3 bytes. It means he will reserve 3 more bytes. Why? He thinks, what is your name?
Harsh.
Like you only compiler thinks. If Harsh tomorrow, if he wants to add a variable, where will you add Harsh variables? You will generally add here. But they will think that you will try to add here, because that's the mindset of thinking that you will add there. Will you add there or will you add down?
Any new key to the struct?
It's
Or
not a
what do you
new
mean
key.
by
See,
new
what I'm
key?
trying to say is, see, today the structure has only 3 variables of 3 types. Tomorrow the structure you will extend, right? When you extend, you will add some new variables, new type, right? So where will you add that new type?
After D, right?
After D,
After D only
generally.
will add.
Yes.
Correct. But the imagination is that this guy reserves memory already, that in memory doesn't have that imagination, right? Memory imagination is what? Today I8, after that I32. Memory imagination is tomorrow if you add something, you will have to add here, right? But programmer imagination is last.
Correct.
Memory imagination is second. You got my point? This is
Yeah.
a concept of structure planning.
Basically, it's like to optimize the memory reads and writes.
Optimization is one thing. The second thing is compiler will imagine, because you choose first 1 byte memory, after that it will think that you will again in future you want to add something, you will add there. But you won't add there. Where will you add? You will add at the last. So what happened here? 3 more bytes will get added. It is unused, and then this guy will take 4 bytes. Again, this guy will take what? 1 byte. Again, below this, if you add something, this side, right? After this, is there anything? No. So that is where that concept comes into picture. Okay. So we will move to next example. Enum is clear, right? Enum variable is 4 bytes. Is that clear? Okay. I don't think so. Running of that program is there, guys. Trust me. Whatever validation you do in Go, the same thing we do in the if statement, else if statement. You see the syntax here. If, elif, else if, exactly the same. No changes. That's why I don't want to simply waste all that time. Okay. Okay. So that is one thing. We have something others to do it. But you can see here. This is something I don't prefer to write. Sometimes they write like this. What I'm writing here in RHS type. In RHS side, I am writing here I32. This is not a good use case. So don't worry about that. So we don't even use it.
We write as
appended to that.
I32.
It has to be appended. They will. It is your choice if you. But generally, no. It has to be appended. So
we should write 16 as I32, right?
16 as I32. You are trying to say that 16 is
Like
I32.
we should like. Is this different from 16 as I32?
No, it's better to write here type in LHS, but you are trying to write down in RHS. Don't do that. Okay, so this is a simple example. Is this clear, guys?
Yes.
So we will move to next part, loop. So here only you see there. Now you tell me what is this array na? Now I run this program. Now here comes a diagram. Anybody can do a diagram, but listen, I have taken an array which takes I32. Syntax already I showed, so you know it. So it is 5 memories array. It is the same. This array is similar to your Go also. It's almost similar. I am taking a mutable variable because whenever we run because Go language everything is immutable. Everything. It's mutable. So that's way. So if you see there, I am writing like this for x in ir.iterator. What will iterator do? You tell me. Guess and tell me. It will create a copy and only give you. Because if you see there, what if I write x in means what? X will also get a data, right? So for iterator, no problem. Nah? Iterator will go to first memory, then it will go to second memory, then it will go to third memory, right? Come on, guys. So for iterator, once iteration gone, second time can iterate that same person? I cannot iterate.
If it's an array of integers, right?
That is array of integers.
So will it work even if we use that in without an iteration? Because it's integer is like a limited data. Like
If it is no, generally what is you're telling about the same example. If you want to do the same example, you can also write for I in you can iterate it. But generally, what is the principle they say is when you are iterating, it is good to access with index. It is good to access with index. Index means see, I'll write for I in 0 ... 5. So what will happen is I will get me 0, 1 like that. So I will use this ARR and I'll pass that ARR with array of I. So it means it is good to access directly with index.
Okay.
If you are accessing it, it is good that way you are trying to access it. So that is one thing.
Somehow
Now
like
see now
how bash arrays are written, like yours, like how bash arrays are written, like 1 ...
No.
1 ... 5.
See, I'll do one thing here. So no. See, I have written already one array here. Okay, now I'll do here. So in my case, I am trying to assign a value here. So I'll write like let something data colon. So I'll write as array which is of I32, 5, which I'm initializing here 1, 2, 3. Okay, I've initialized. Let's say I'll initialize here 3, and let me write down let. Okay, a variable name is something C, which is, are you right? Let mute variable name is C equal to data of array of 0. What did I do now? Data of array of 0 is what?
1.
Now, because you have written there I integer, so you are trying to do a copy to that, right? Now see what I'll try to do here. I'll try to print ln. Now inside this, I'll try to pass what is the value of data. I'll write down here. I'll try to pass what? Data of 0. So what will happen in this case? Sure? It's 1 minute. It is
Integer,
1,
it
2
should be
point,
available.
2 point. It should be available. It is a type. But listen, I have studied it. That is also not possibility you can do. I will give you that. I told you that today morning because they are trying to solve that problem. No, boss. Morning I told there is a function fun2 fun3. I passed A to another function. One more copy happened first. Again, one more copy happened first. So what happened? There are 3 stacks.
Yes.
You're getting 3 copies. Yes or no?
Yes.
They are trying to implement. I've done that, but I'll give you that confusion as well. So we'll write down here loops. 1 minute.
2.1 L.
2.1
L.
So what is the error you're getting?
You have to do colon or semicolon or something.
S.
So the syntax is a big problem.
Syntax every time I'm also doing mistake because very honestly I try to byhack it. How much I try to byhack it, I'm not able to remember it because they're using in between no one is symbols. I remember Go. I can write confidently Go. But the rest is a problem that they are inserting so many symbols. So I can tell with memory layout, but don't mind that I'm doing mistake. Okay.
Is there a nice way to get the red lines in VS Code? If you have found it, please let us know.
I'll tell you that.
Google should
So this auto completion options are there where it will.
I wonder how Mozilla developers write.
Like for example, if I say like let data equal to, I will start the square bracket, I put I32. And if I press control space on auto completion, whether it will be semicolon and
that option, I think they
it's
are
an
not
editor thing. It's not
editor thing, but that option is still not available. I guess.
So Rust
I'm not sure
analyzer-
it is not. What I am, no, it's not available. There are.
There is
Where you have-
there are 2
which
things.
ones? I'm
Rust
not sure.
analyzer and type
Rust.
type racer.
Rust plugin we have to install.
But Rust plugin he has it installed.
Edit something in mine also it's not working. In mine it is working. If I do dot, it will show all the methods.
Every day I open, I get a new Rust analyzer in my VM. I don't like it, and it doesn't work.
Yeah, I've used semicolon.
Colon hai kya? It's colon, right?
I've
Let me take a look at my Rust learn.
red
I have a repo called Rust learn where I've done some data
तो ये तो
structure
हो
work.
गया ये shop right
Somewhere dot is showing here.
I think it's a file
कौन
name.
सा next वाला ना analyzer
File name.
File name. Oh,
Rust
sorry.
loop.rs, no?
Our thing because invalid character. No, in the create name. Oh, okay.
Because the file name
Yeah,
is
because
file
of the
name
file name. No, file name it doesn't create a problem.
Yeah, this is not Windows. Sai might have sent a message.
Something I think they have.
Give escape character, or we can do it in double quotes. Rust C double quotes 2.1 loops.
If you
अच्छा ये तो bash का error नहीं
bash,
है.
it will give you this error. Okay, no problem. We will.
do dot slash
It's okay. We will try to create a new file. That is not going to create much time.
New file name was
File name is a problem. Yes.
Nandan, please tell your setup कैसे how it works. Create ये create कैसे हो गया ये? By default create ही बनता है.
वही तो बोल रहा हूँ file name show.
That's what file name is the problem.
Rust layer, struct Source.
So please run that program and try it because that's where you learn something there. But actually there is a way. If you give me a time, what I'll do is I'll work around. There are some shortcuts. Okay. So I'll send it to your boss after this session, Saturday, Sunday. I'll sit down and create some shortcuts. And my Monday I'll try to send you some shortcuts.
Shortcuts regarding what?
For all the syntaxes, all the things I'll try
In
to
completion.
on the completion of that I'll try to send.
वो करना जरूरी है.
Uh-huh.
बनाएंगे विजुअलाइजर बनाएंगे रेस्ट का अगर समझ गए तो
Memory visualization.
वो बहुत
Yes.
जरूरी है.
So guys, is this a program running?
Looks like it.
Yeah, it's running. It won't have any problem. So you can see that the data is copied to another variable, but still the data is not code, right? Correct. So you can do this as well. So now I have a question. If you can, see now there is one more point here. When you are iterating it, so this data is getting copied, right, to X variable. So generally some people will use references if they want to use, but it is not a problem here. Okay. Now what we will do here is, so imagine if you want to pass an array, okay, how you can pass that array and how you can receive. What is the best option? Okay, now one more point. Wait. One more point. Imagination. Let's do. We saw now slice. We saw string. Both are objects. What is array?
Objects.
Array is also object.
Yes.
Okay. Now, if you want to pass this array, how we can pass?
By
So
reference.
To a function.
So two ways, right? Either by value or by
You can copy by value or copy by reference. So which is the best approach?
Reference.
Okay. So you can always try to. Generally, you try to put it as a reference only. That's where you do it. Okay. Now there is an interesting topic for you coming on the way. Okay, but anyhow, I'll talk about this. Anyhow, we'll talk about this, but anyhow, I'll tell you this guy here now itself. Anyhow, we have come so far. So you heard about function pointer?
Yes.
No. You didn't hear about function pointer? Okay. I don't know why it is not running. Okay. So I will also talk about this. There is a reason for that. The reason is you'll be using this more in your frameworks. You'll be using this more in the frameworks. Only fallbacks. Now, okay, hold on. So anyhow we'll understand. Guys, for you it is offer. It is not much challenge for you. I mean, the Go language developer. It's not there, I guess. I've recently only added it. So if you see, one minute. I'm not sure. Do you know this or not? But actually, this is a secret that you have to know here. So if you write a function name, guys, if you write a function name, fun1 is a function name. Okay, this function name also has some address
In the code segment.
Exactly, you got that point. This function name also has some address. This address is stored in a memory segment called code.x. Okay, so generally I'll tell you for them in Go language, you would have seen a function like this, unnamed function.
Directly called.
You are registering.
Yes, directly called.
You're telling I am Baba, you take my code. Okay, I am Baba, you take my code. And who will execute that code? The library will execute. Because
function.
that's what it is a code. This code you give to library. Because you say you execute, I don't execute. Correct. You do it. Generally, what is an API? API is executed by the framework. Correct. You write a name of the function and give it to him. So that giving is when you are giving it, how will you collect? With the help of function pointer. Because we will do that, right? So we have to pass it and he will receive it. So to collect that only you see. So that's why in Rust we will pass. Because this code you will do in Actix framework. When you are doing it, you will have to write a function, and I'll show you that time. So it means now listen, there is a function name. What is the function name? Fun1. Okay. I'll call a function called multiply and I'll pass fun1. So here in multiply, What is the type I have to write here? Oh, int. This is type is function here.
This function.
So what I should write? Fun like this. Come on,
Yes, yes, yes.
fun like this. If there is any written type, you will write arrow enter. Suppose if this function takes I32, write I32. Here colon A. A is a is
Function
also
pointer.
object. Yes, is also object.
So you're saying that function is a first class citizen in Rust
Yes,
also.
yes. So you have to, because you need to know this clearly, because you will be using three things more in frameworks: function pointers. One is you will be using traits, you'll be using structures, you'll be using methods, you'll be using data structures. Data structures very often. It means the design will be a little different. We'll do that. It means what? Half of the design of the code we write, half of the design he will write. Are you getting? So for example, I'll just tell you the designs tomorrow, but not today. Okay. Now this A will point to which function? Guys, this
FN1.
Wait. I'm FN1 is a function. Multiply is a function. Inside the, I'll write one more function here. Set. Fun set.
Yes.
Now set is a function. Set function takes nothing. Let's assume. So I'll pass here what? Set. If I'm passing set, or if I pass address of set, it is both same. If I want to surprise it, this is a syntax in C language you will write.
Yes.
He's not surprised. He said, okay, French type. This is a syntax, correct? The pointer which will hold address of a function. So I don't specify anything. I'll write here A. A is not a, but internally this is the same. So there are two approaches we do in Rust. One, we pass ampersand rest, ampersand set, or will pass set. Don't get confused. Ampersand set, or set. What do you mean by that? Is there any ownership concept here? Think, will they implement ownership concept? You have to use your brain. It's time to use your brain very effectively.
Code section is there throughout the execution of
Yes.
the program. And
So
it
what will
cannot
happen?
be-
You cannot be a owner.
Yes.
You will only be reference.
So there's no borrowing
No
ownership
concept
here.
at all here. I'm very happy. He's
So
very
only
happy.
for functions.
Yes, only for functions. They will implement like that. So that's why if you, I will execute this program. If you are passing address of multiply, or if you pass multiply, don't get any confusion. Works same way. If I'm passing now, there is a function main. Inside that, there's a I'm passing 5 in address of multiply. Correct. So there, when I'm passing my function, what do I take? I pass value which takes I32. Yes, sir. No, guys. For F1 type is what? What I have done there? Ampersand only I have done, na?
Yes.
So
Yes.
what is that I have done? I have
You
done
are
the
passing
ampersand.
reference.
I am passing the reference.
So it doesn't.
So what did you
So
say?
it doesn't
matter.
matter. No. If you
I'm
pass
just
both the
saying-
way, I have the other example. Both the way it does, because as per my understanding, you cannot do that concept here, because if you see here.
I think in Golang we can't do AND function. I think we have
See here.
written.
No, see here. I am. What is this guy? I have a function. F is type function, which is pointing to what? Add
Add
one.
one.
Calling 5.
We are calling add one indirectly.
Now, if your F is pointing to add 1, add 1 is a function which takes I32 and returns I32. Guys, this line is going to return. That's it.
Yes.
So I can call this. I will take this value and give me that.
Is there a scoping concept here? Like add one, can I define a variable called add one inside main, which will take higher precedence over the function?
No. That is. If I'm not. Can you put your question in a different way? What you're saying?
So before the line number 10, right? Okay, can I define a variable called add one? Integer variable called add underscore.
It's talking about a closure, so like a closure function inside main function.
Normal variable.
Normal variable.
I'm saying like the
Conflicting
first-
names.
a simple stack variable, simple variable inside main function, whose name is add underscore.
I don't think you can do that
No.
because
No, because you can declare a variable, but okay, your question I understood. See, in Rust we can do shadow. They call shadowing. If you write two variables with same name, it will work. But both the variables type data should be different.
yeah. So in this case, it will likely
You can write let A equal to 10.
it will be a
Let
compiler.
A is equal to 2.3. So it will treat this both A's are different way. So is that I'm giving you a
Yeah,
correct
but-
answer?
So this function, right, or this code can you just compile faster?
So in that case, Vishnu, like in shadowing golang, it takes the closest one it has
Yeah,
access to.
local.
It has
Local
access.
one
No, you are
can
talking
have
about,
precedence.
see, I'm trying to understand your question. You are telling there's a global variable with same name, local variable with same name. Is that the point you're telling? Okay.
So the scoping is what I'm.
Yes. So if you write a local and global variable, so generally it will give a priority to the local only.
Local only, but in this case, so the types are different.
So in this case, what happened is this function is add one. Add one is always a global, because generally what we do is I'll tell you. You can make a function private. You can make a function public. Instead of saying that it is global, I would say that function is public. Because it is public, you are able to access this scope. Because outside the scope, you are able to access the scope.
Right, it's in the same file.
It's
if
in
you
the same
don't
file you
even-
can access. So I'll show you an example where I'm creating some modules, where inside that module I will not write public. Then that function becomes private. I cannot call. So that their scope, I'll just show you that. So now can we run this program?
Yeah.
So
this should return 6, right?
it will return 6. This is a way it will do. So this program is function pointers. So you will get this. This is how it happens here.
If you go back to the multiply function, right? Multiply.
That other one, I'm going to that program.
So there, what will be the value of, or like?
So in this case, what happens? I am passing an address. Okay. I am saying I'm trying to pass an address. Okay. But you see the type of what I've written there. It is, if you pass an address also, you're saying like reference, but generally I said that it's a memory segment.
This is like a
you
constant.
cannot do that. It is
Like
anyhow,
a
it
constant
is a
pointer.
constant. You cannot do anything with that. So it's a constant pointer. It will point to that memory address only. So
even if you drop the ampersand in line number 2, it will still work.
But you have to, that's why it is better if you are writing address of multiply, this function you are passing. This F will point to this function. Now this is like registration. Registration means I am writing my code and giving it to library. So assume this my function is library. You didn't write it. An example, my function is a library. You call that function and pass 5 and multiply. Multiply is your function. Okay, this from 6 to 12 is your code. 1 to 5 is library, let's assume. So you call this function and pass this. The execution of this function multiply is in the hands of library. It is not in your hands. My function only will execute, but it is not in your hands. This is how all your API happens. In APIs, you will write a server. To server, you will give all the functions.
It is called back. It is called
And
back.
this server, whenever a user in URL says hello, the server will go and check for the string in that registered function in the linked list. It will check. And if it is present, it will go and hit that API, and that API will give response. This is how they work.
Where you are saying?
Router.
Mux.
HTTP.
In Gorilla Mux and
Mux
everywhere
also,
they are doing the same.
The map with the endpoint string.
Okay, so we'll run this. So function pointer 1. So mostly when you're working on this, so we will not generally worry about that. So you can see there, it will give warning. It will tell you what. See this. So can you see that what it says? Var bear trait objects. Not to worry about it. What are you trying? It is telling you. You are writing here ampersand. You are trying to write ampersand, and you are writing this fun and this type. So you will write on what this type? dyn. What is the dyn keyword? It is dynamic. So if you say dynamic means what? To implement the concept of callback, there is one villain is going to enter. Interested. And for that concept only, what is that? Can you see this? Dynamic is there or not? Right. There is a dynamic trait object is there or not?
Yes.
So he will implement you lot of callback mechanisms here. He'll implement you lot of callback mechanisms are there implemented here. So we'll talk about that. Don't worry. We'll talk about that. So anyhow, this is a thing. So we will run this guy dot slash one pointer. So can you see that you will get the value 25? Correct? So you have passed the value 5 and address of it. You have received this 5. Here this guy is pointing to this function. Yes or no? He will execute this. He'll call right f of value. He'll pass, execute it, and get the return value printed here. And in fact, after that's what he is printing you that value, and he is returning you something, but you are not collecting.
So what is returning is still only 5, right?
No. He is returning a value what he passed. It is written still 5 only. I'm not collecting. I am not collecting that part, but it is returning that constant. Okay, this is clear. Okay, fantastic, guys. So now what we will do here is
One quick question. Why is that FN F is in uppercase and not lowercase?
Which one?
When we are receiving the function, right?
here. Okay. Whatever you have written is you told is very good. It's a very good question what you asked. Because if you write there ampersand FN is again a kind of object which is not you have we defined. It is a type kind of thing. So if you, it's a very valid question what you have asked.
Or it's like a constructor?
No. It's not like a constructor, but it is. It will be having a lot of things. It's like a constructed object. I'll tell you one. If you go here,
String or box like that.
no. If you have looked at here, I have straightforwardly used here this add one. Okay, and the type also I've just specified there add one, and add one is this. It means if you are looking at the concept here, in this case, what happens? Actually, you are passing multiply. The type of f is not the type of f. If you see here, 1 minute. So what is the type of this? FN. It means you had. That's what it was referencing. FN and add one is just referencing same memory and calling. Yes or no? But if you see here, so what you have written here, ampersand FN. It means now it is not a direct way of calling. So there is someone who's coming here. Okay, and that is where write comes into picture. And because he comes and execute this code, so it is in a way of indicating that he wants to execute it. So he takes care of he takes care of mapping of this function. So he maps this function. It is not only this function, so you can choose it whatever type of functions you can do. Generally, if you are calling one function, the function to which you want to call, the type you have to specify, correct? So it means the argument type, the argument type and return type should be same. But if you use dynamic trait, you can do a lot of things. The dynamic trait type of object will help you to do a kind of
accept any kind of function signature.
But because it is generic type of it, so it will handle it. But I'll tell you a scenario for that how we will do, because I will try to show you a way of implementing a trait for a structure which is generic, and I'll try to show you that code tomorrow so that you will understand how we can do that implementation. Okay. So we'll move to next thing. Okay, I think the last one's example we'll do here. So, before this example may need you a lot of time to make you understand. So anyhow, we will do this. So one quick code before we go for lunch. So can you see this example?
Yes.
Can you tell me what are we trying to do here?
This is the
Making a
vector type
function.
example.
So if you see that there is a structure string, a structure student, which takes name string, school string, roll number is there, grade is there. Name and school will point to which memory?
Heap.
Heap memory. And value one. Now
Stack.
inside this value one is this. Now this,
Stack.
what does happen here?
So
As
I
value
can
one
copy
is
learn from
will copy.
copy and
Okay. And after that? I'll point to that guy, right?
So that is a closure function.
Not a closure function. See, I just told you, this is you will get a copy of it. So if you pass an object by value, then your ownership concept comes, right?
No, sir, I'm saying student detail is a closure function.
Oh, it's not normal function. Yeah, F1 keyword
Because
is
it's not accessing anything from.
there. F1 keyword is there, and you're passing. F1 is a keyword. It's a function, a written type of this.
Okay.
The written type of the function is what? Student. And I'm creating an object inside this function. It means this is, you can say, instead of writing it as student, so you can also do one thing. And one more point I would like to tell.
Sir, one question.
One more point I would like to tell is that if you are from a different background, in fact, you are from a Go language background, in C language, inside a function, we cannot write a function. In CPP also, inside a function, you cannot write a function. It is not possible. In Go language, you can write inside a function. You can write a Go routine is also kind of special. You can write it. You can do that. So here, why they introduce this concept of writing inside a function is it is a kind of static function. Static function means what? You can implement static function in Go Rust two ways. One, write a function. Now this function is there. Which function? Or you can write one function. See, example is this guy. This guy is what type of function? My function is what? It is like a normal function. So this function is like, you can say it's public now.
It does not have
Global
log.
type.
Okay, take it.
Further, if it is,
okay.
I'll tell you, there is a difference here. We can implement encapsulation, everything in module we can implement. Where? In module you can implement. I'll show you. In module you can implement encapsulation. You can implement abstraction also. It means inside a module, I will write a structure. Inside that structure, for that variable, if I write public, only that structure variable is accessible. If I don't write public, that variable is private. Because the reason is that Rust will follow encapsulation abstraction concept of C language. It doesn't follow the encapsulation abstraction of CPP. I will explain it in board so that you will understand clearly. Okay. So what I am trying to tell you here is this function is now public. Okay. Now if I write inside of one function, then that is a kind of private.
It's not scope to.
The scope of that function is visible only to that. But if you pass that function to someone, if you register it, they can exhibit. You can exhibit it. If you want, you can exhibit it. Okay, enough. After lunch we will do so that